There you go. Okay, so we got the intake port comes in this way. The arrow goes that way. Exhaust port goes that way, like that. So that's the exhaust valve. That's the intake valve. That's, so if you guys need your house financed, which I would strongly suggest, rates are going crazy, and the way they're borrowing money, it ain't going to get any better. If you think you could benefit from a consultation, I would strongly suggest you get a hold of our good friend Vadim, who is a good guy and a good guy to look towards for stuff like that. Because I got to tell you, don't matter how much money you make if you don't keep it, or if you're losing it through poor financial management.
Yeah, it's good to use good opportunities, you know, because when it's good opportunities, rather do this late than ever, you know. Sometimes.
Right. Every opportunity has an expiration date. And what we see is the expiration date, the window is closing on the good rates, which could amount to tens of thousands of dollars over the course of the loan, which probably would, because you know how those things work.
No, it's a couple thousand a month sometime, you know, when there's
Right.
a lot of consolidation.
Yeah.
No, that's true.
For me, it was almost $100,000 every 3 years. I mean, really?
Wow.
Yeah. So, right. So this is the direct injector. Yeah. Can you believe how freaking stupid that is? I could have bought an apartment building if I, right? Because I had all these hippie teachers that told me, oh, only losers think about money. Yeah. Okay. Well, the only people that don't think about money are people who always had it.
Yeah.
Spark plug. Anyways, I'm just suggesting that, especially if you have an adjustable rate mortgage, I think it's going to be crazy inflation. I don't see any way there can't be. So we need to tighten up. What do we need to do, Chuck? We need to get more sellable skills, right? We need to learn how to fix more stuff and maintain more stuff, because especially for like people on fixed incomes, you know, you think your pension's pretty good at $8,000 a year, but what if the price of everything doubles? $8,000 a month, $8,000 a month. What if the price of everything doubles? Now all of a sudden you're poor. So I'm nervous about that, you know.
Yeah, and we're moving a little bit towards inflation, you know, in the market.
Yeah.
Yeah. Well, if we're only moving a little bit, it won't take long. We'll be moving quite a lot.
The only thing is they're delaying the bigger crisis. They're like kicking the stick longer and longer.
Right.
Yep.
So, well, you keep borrowing money. I mean, it's just like a credit card. Just like people figure the bills never come due. What the hell? No, you know, the bill is going to come due, but you know who's going to pay it is all of our kids. That's freaking sick. That's disgusting. It's disgusting that that's the legacy we would leave them. Literally disgusting. Okay, so it looks like this. See, we got the direct injector and direct injector, where the spark plug would usually be in a Hemi, and the spark plug's over here to the side. Now, what does the direct injector do for us? Well, see, the port fuel injector would normally be over here in the intake port. This is spraying directly into the cylinder. What does that do for us? Well, a couple of things. Number one, it makes it so we can spray.
Bless you.
Excuse me.
Bless you.
It means we can spray less fuel, excuse me, because what happens is
coronavirus.
When you have an injector over here, the fuel gets in here, but it's not going to be evenly dispersed. As a result, we're going to have to spray more fuel than we otherwise have to, because some of it might be over here or some of it might be over here. We got to have enough fuel to give us the proper emissions and also to avoid a misfire. Well, look, if the injector's right there, it makes it much easier to get the fuel that we need right where we need it, which is near the spark plug. Now, this brings up the second advantage to direct injection, which is what's called stratified charge. Stratified charge means what we're going to do is we're going to put funky shapes on top of the piston. So when the direct injector fires, it's going to shoot the gas straight at the spark plug. Now, when the spark plug goes off, we're for sure it's going to fire, right? As a result, we can run a much leaner mixture. And I'm talking about, 22-to-1, super lean, super cruise. Yeah, 22-to-1, which is insanely lean mixtures. Now, can you do that with oxygen sensor? No, you have to use an air fuel ratio sensor. But this is why we're changing technologies. That's why, for instance, we've gone from an oxygen sensor, which is considered a narrow band, to an air fuel ratio sensor, which is considered a wide band, because it can measure a wider band of air fuel ratios. And one of the things we want to do is, like when we're driving down the freeway, it's a level road and we're going 60 miles an hour, it probably only takes 10 or 15 horsepower to keep us going at that speed. Okay, so we can go in, and that's why, for instance, we're going to shut off the alternator. Now we're going to get some real gas mileage, right? Okay, well, let's do this. Let's lean out our mixture to like 22-to-1. Why not? As long as we don't need to accelerate, we don't need it any richer than that. Now, how are you going to get 22-to-1 to even combust? Well, here's how, because I'm going to shoot this freaking fuel and it's going to go straight for the spark plug. That way I know it's going to ignite. Stratified charge, that means different levels. Okay, now we talked about deposits on the back of the intake valve. I'm trying not to rush, but I'm really excited about getting back in the shop. Not really, I'm just excited about getting my Corvette running. Quack. I'm excited about you getting my Corvette running.
I have a quick question. Quick question.
What?
When is the semester over?
Semester's over like May 20th.
May 20th? So
Yeah.
that's like a month and a half, maybe?
Yeah. Well, no, that's, yeah, about a month and a half. Well, at this point, probably 2 months.
And then it starts back up when?
I don't know if they're going to have it in summer. That's an interesting question. I should find out. Usually they don't, but yeah, it would be hard to find teachers that just wanted to teach night school.
But
I
then-
think they should.
But then it starts all over in the fall, right? And we probably will be in the shop.
Yeah. Oh yeah, for sure.
Oh,
Especially you guys.
yeah.
Especially you guys. Yeah. Because
All right.
what's the point of teaching you how to change oil again?
Yeah.
Okay, so incidentally, Chuck, I need to drive that Suburban out to the desert March 13th, which means I need to get that Suburban going. If I get you a little helper, if I get you an apprentice, can you come over and supervise my radiator R&R?
I told you I would do it for you.
I know, but you're jacked up, Rudy.
So I don't give a shit. I'll do it for you. Just give me the radiator and I'll come over and swap it.
I know, but I'd rather have one of my minions do it because I'm trying to.
Well, I could supervise them too.
Okay,
I do know how to
I know, but Chuck's trying to get something from me, and I'm trying to. Yeah, Chuck's got some stuff he wants to get from me. So, unless you're like super low on money, because I also need to change out the master cylinder. So,
I can always use money, and I don't care. I come over and help you do whatever you need.
All right. Well,
You know that.
Yeah, thank you. I offered it to Chuck first, so it's up to him. But you can always watch a YouTube video, Chuck, and learn how to do a master cylinder swap. It was a joke, but I'll get you a minion to do all the hard work. But
Or ask me, and I'll come help you, Chuck, and we'll get it done twice as quick.
Whatever works, just give me a date, time.
All right. You're usually free on Saturdays.
I got a job on Saturday, this Saturday.
I can do it whenever.
I could do it Sunday.
Well, probably not this weekend because hopefully I'm getting an appraisal this weekend. But,
Okay, well, next set, next set after that, I should be free.
oh, cool. Okay, I'll let you know. Thank you. Yeah, Rudy, I don't want you guys to struggle through this. I'd rather hire a minion for cheap and put a little money in their pockets and have them do the hard work because.
Hey, I don't mind doing the work. Shit, I feel good enough now. I want to do the damn work.
Wow. Okay, well, I'll pay you $5 an hour, cash though, and I will give you all the Gatorades you can drink, but none to take home. That was a joke.
I'm down, whatever.
Okay, so I'm glad you feel better. So stratified charge means in this circumstance, we talked about deposits on the back of the intake valve, because what happens is the oil comes down the guide that goes around the valve stem like this. The oil comes down past the valve stem seal, and it comes down and hits the hot part of the back of the intake valve, and it just turns into a briquette. You know, a diamond is made of carbon. How do you make a diamond? Heat and pressure, right? I mean, it's basically made of the same stuff a graphite pencil lead is made of.
A coil.
Yeah. Heat and pressure, right? So what happens is when the oil comes down, it's called coking out. When the oil comes down, the carbon just solidifies into like a charcoal briquette. And that screws up the airflow, jacks up your drivability. Primary symptom is hard starting when it's cold, because it jacks up your airflow too hard.
How do we fix it though?
Okay, there is engine treatments to clean this up, but if it gets too hard, guess what you got to do, Rudy? Go ahead and tell them.
Rebuild.
Take off the intake manifold and go after the valves from the back.
Okay, so what do I need? Give me an idea so I know what to buy to try to run it in my flex and see if that's why it's having a hard time starting.
Do you have any experience on this, Chuck?
No, I mean, you could spray a liquid cleaner in there.
Okay.
You could do the walnut cleaning.
First.
You know, I haven't had experience with that,
Oh, yeah.
but it's gonna be tedious, you know, and you got a lot of towels if you're gonna do it the liquid way, you know.
Yeah.
And you're gonna do one compression at a time, you know, each valve a compression stroke. You don't want none of that going down into the cylinders if you're doing a walnut.
Right. Yeah.
What is that when they blast it with walnuts or something?
Right.
Shells?
Right.
Shell,
Interesting.
that's your name. That's your nickname. So anyways, my point was, yeah, so we want to make sure that this doesn't happen, or if it happens, we get after it. Because once it gets really, really bad, you ain't gonna get rid of it with no liquid treatment. Now, what the manufacturers have done since they've recognized this problem and it's become a problem for them, what they've done is they've started putting port fuel injectors back in. So now we have systems that have port fuel injection and direct injection. You say, well, isn't that two fuel systems? Yeah, it is. Doesn't it take twice as much computer to run it? Yeah, it does. But what it does is it gives us the fuel economy and efficiency of direct injection without having all the problems with airflow created by carbon buildup on the back of the intake valves. Now, what it also does is it enables us to run a super lean mixture coming out of the port fuel injector, something that would never light off by itself. But then we squirt a very small amount of fuel. It hits the top of the piston, which is shaped in a funky way, and it shoots straight towards the spark plug. The spark plug ignites that small bit of fuel, which then ignites the otherwise lean mixture that would never ignite off of an arc. But it'll ignite off a blowtorch, right? Now, look, this is, you want to see how I got kicked out of LA Unified? He said on camera. All right, here's how I got kicked out of LA Unified. Look, here's a lighter and here's some fuel, right? Can we all agree? It's a book, it's made of wood, that's fuel, right? Okay, so even if I hold the flame directly on the fuel, it won't burn. Why won't it burn?
Not hot enough.
It needs oxygen.
It needs oxygen. Because what happens is when I'm holding the flame to here, the only oxygen is on this side and on this side. Everything else is surrounded by fuel. Now, let me take one page. See, one page. Let me take one page and I'll hold the flame even farther away. And what happens?
House down.
Take your house on fire?
Yeah, set my house on fire, right? Why? Because when I have just one thin piece of paper, it's surrounded by oxygen. And combustion is an oxidation reaction. And that, my friends, if you ever want to get kicked out of LA Unified, that's how you do it.
Wow.
Oh, you should have had, they actually said, you should have had two people standing by with fire extinguishers standing next to you.
Come on, really?
Make the fireworks.
Right? Yeah. Now I got ash all over. I got ash on myself. Yeah, the point I was trying to make was, So you excited about going back to the shop yet?
Yes.
I am. But that, we got to do the safety test though. Yeah, we do. I wonder if that's online. I wonder if that's on. Well, that'd be good if it was online. I could put it online if I wasn't so freaking lazy. So stratified charge just means, okay, let's put a funky shape on top of the piston so that when this fires, it just goes straight to the spark plug. That way, for sure, it's going to light. Now, when this is a big old explosion, it's going to be able to ignite a very lean mixture that wouldn't just ignite from a little bitty spark. Get it? That's called stratified charge. And Chuck is old enough to remember back when Honda did this with the CVCC. It had three valves, 2 intake valves, and one intake had a very small but rich mixture, and it also had a 3-barrel carburetor, didn't it? And the other one had a regular carburetor that was running way lean. And what we did was we ignited the small charge of fuel that was rich, and that was enough to light off the very lean mixture. And that's why the CVCC engine made good fuel efficiency. And it really, wow, that's really interesting. Isn't that interesting that Honda came up with the CVCC and with VTEC? They've had a lot of really innovative engine designs, really, if you think about it. Stuff that nobody else did, because nobody else followed them, put it that way. So maybe it wasn't that great of a design anyway. Okay, so that's what direct injection looks like. We've talked about stratified charge. We talked about how expensive it is to replace direct injection components because the pump's like 3,000 PSI. So you can imagine it's going to be crazy expensive, and the injectors are going to be expensive too. Basically, it's, as we said last week, it's a diesel fuel system. Also, I didn't get the last week's session on YouTube yet, but I'll do that tonight. Hey, I figured out how to make Thursdays tolerable. You know what you do? You quit thinking about Thursday, you start thinking about Friday. You know, because I used to dread Thursdays. Like Wednesdays, I'd be like, oh my God, I can't believe how freaking bad I'm going to feel tomorrow. And then I feel bad on Thursdays. But now it's like I came to the realization, I started thinking about Friday and I got so happy. I came to the realization, all I got to do is think about Friday. Quit thinking about Thursday. It's like if you quit thinking about the scab, it doesn't hurt no more. Yeah, that's an example of sorts.
Or think of Saturday where you don't have to wake up early.
Well, that's too far.
Oh, I want to get to sleep in.
Yeah, that's like thinking about retirement. It's too far away. So my point was that let's talk about ignition systems. And I don't want to get too much detail just because we're running out of time. Plus, it's supposed to be a beginner's class. So all we need to know is the purpose of the ignition system is to fire the spark plug. The purpose of the spark plug is to ignite the air fuel mixture. There we go. Sorry. Purpose of the ignition system is to fire the spark plug at the right time and the right amount. The purpose of the spark plug is to ignite the air fuel mixture. That's all it does. That's all it does. Now, okay. So this guy calls me up today and he said his mom, her car died. So she took it to a place that ends with Stone, and a national chain that ends with Stone. Don't say it. And,
Flintstone?
Yeah, Flintstone, exactly. And they told her that they needed to replace the camshaft position sensor, the crankshaft position sensor, and all the spark plugs. They wanted to charge her $800. So he went down there. Said it sounded fishy. He actually called and talked to the guy on the phone, and the guy was bloop blop bleep blop. Did you pull the codes? And the guy says, oh yeah. And he said, okay, what codes did it have? This guy used to be a helicopter mechanic for the Army. I said, yeah, that's what you do. Ask him what codes it has. Okay, so he goes down there. Engine won't even crank. Will a lack of crankshaft position sensor, camshaft position sensor, and spark plugs stop the engine from cranking?
No.
No. Good. Well, evidently, Michelle, you know more about this than the professionals that work at Flintstone.
Wow.
So he went down there, he opens up the hood, and of course there's corrosion all over the battery. Corrosion all over the battery. So have it towed to his brother's house. He gets in there, he cleans off the corrosion, puts it back together, and
Fires.
he went out. Yeah, it ran. And he took the cover off the spark plug wires, and like some of the spark plugs were loose. Like, this is what happens when a place like this gets news that you're towing your car out of there. They jack up the car. Remember what they did to my Suburban when I caught them trying to jack my wife out of $1,300? Anyway, so he changed out the spark plugs, and guess what? Runs like a freaking dream.
Yep, doesn't surprise me.
Yep. Freaking punks. Yeah, that's my industry, right? So it's like when people talk to me, they're thinking about them. Freaking punks.
Yeah, that
Unbelievable.
sucks.
Yeah, just gonna rip off an old lady.
Cliff, you're so passionate.
Well, no,
Well,
because the bad
that
people
me?
always mess it up for the good people. Like they ruin it
that
for
me?
everybody.
They tried
Oh.
charging me like over $600 to get my brakes done.
Well, I paid 800. Don't feel bad.
Okay, Gabe Alvarado, I gotta ask you a question. Why would you guys even consider having anybody do your mechanical stuff besides Chuck Reyna? I don't get it.
They didn't know Chuck that back then.
Oh, okay, back then. Okay, okay. There you go. Okay, but from this point forward, if we're not in the shop,
Oh, check.
yeah. So my point was, if it wasn't for people like
For
that,
me.
yeah, sure. If it wasn't for people like that, I could get paid a lot more. I mean, real mechanics would get paid more. See, because the state of the profession is, it's not considered a profession, it's considered a skilled trade. Why? Because of jackasses like that. In fact, it's not even considered a skilled trade for most people, because, I mean, anything you can learn in 3 days doesn't count as a skilled trade. Okay, well, it's people like that who ruin our reputation and also keep us from getting paid.
Yep.
So, yeah, besides, you're beating up on an old lady, it makes you trash to me. That
Yeah,
makes
I
that
agree.
makes you my freaking enemy,
I
right?
agree. Mhm.
Because I am
It
on the side-
was Brooklyn. It's
What?
because she's a woman and she came in by herself. They assumed she didn't know nothing, had nobody to tell her nothing.
well, I'll
They
tell
were
you
just
what,
like, well, okay, we know that we need to replace all these parts. And she's like, oh, parts. Oh, okay, yeah, I guess those are bad.
Well, a lot of
Okay,
people don't
Luckily,
know.
she
You know?
had somebody who actually knows a little something.
yep, we got to get on. So it goes like this, folks. You need to understand. People like me have to work really hard to make this civilization work, right? Tax-paying citizens, we work really hard to make this civilization work and make this society work. And when someone comes along who's preying on innocent people, who's preying on good people, who's preying on old people and women, that makes you my freaking enemy. That's why I'm passionate about it. Because that makes you my freaking enemy. Because I work so hard to build all this and you want to freaking tear it down. That makes us enemies. We ain't homies. We ain't friends. We ain't even colleagues. We're freaking enemies. So there you go. Yeah, that's interesting. Where else are you gonna hear stuff like that? It's true though. It's true though. All right. So you know, what we see actually in this country is a failure to appreciate how hard people work to make all this happen. And that's why we're willing to throw it away, right? Eat all the seed corn. All right, so the ignition system goes like that. Now, what should I tell you about the ignition system? Well, I will tell you that the spark plug looks like this. Yeah, I'm gonna have to go like this. R42, that's a part number, little Santa's hat. And then it comes like this. It goes like here, and then we got this little bevel right there. That's just an angle. There we go. That's the spark plug, la bujia. Now, this part is porcelain. Why is it porcelain? Because porcelain is very hard. Incidentally, I know someone who wore a mask full time at work for a freaking year now. And guess what it's causing? It's causing tooth decay like crazy because now the bacteria can't get out of your mouth. It's just recirculated. So it's causing insane amounts of tooth decay.
Great.
Yeah. So probably,
Dentists are having a field day.
yeah. So the dentist contributed to the politicians responsible. That was a joke. All right. So anyways, this part right there is a seal. That's where it seals with the head. And this part right here is where it
Threads into the head.
The head, cylinder head, that is. Call it a cylinder head because it's on top of the cylinders. Screws into the head, which is grounded. There we go. This is where you put the socket. Now, let me show you a little stuff just so you'll know. Where's Gloria? I told everybody that you got this class for free. All right, all the shaded part is made of steel. Steel is a conductor. It's also very strong, so when we're screwing this into aluminum heads, we're going to be very, very careful to make sure to do it right. Never remove spark plugs when the engine's hot because aluminum's soft when it's cold. It gets way softer when it's hot. And if you pull this spark plug out of a hot aluminum head, it's going to bring a bunch of aluminum with it. You might get away with it once, might get away with it twice, but the third time when you go to tighten that spark plug, it's just going to keep on spinning. Then you got a big problem. So this part is steel, that part is steel. This white part is made of porcelain, which is very hard. Now, why do they make your toilet out of porcelain? Because since it's so hard, germs can't get in it. They don't soak into it. They just stay on the surface where it makes it easy to clean. Now, you have enamel on your teeth that does the same thing. That's a hard part. If the hard part wears away, then you get to the soft part. Well, porcelain is very hard. Now, hard has a specific connotation. Hard is not strong. See, a lot of times people think hard and strong are the same thing. Actually, it's the opposite. Now, if you take a piece of steel and suspend it from 2 points like this, and you put a lot of weight on it, it's going to bend. But when you take the weight off, it's going to spring back to the way it was. That's strong. That's strength. Porcelain is not strong. Porcelain is hard. Porcelain is like glass. If I had a glass rod right here and I put a bunch of weight on it, what's going to happen? Because glass won't bend. It'll break. And the same thing's true with porcelain. That's why you don't get dents in porcelain. You get chips. Right? Because it's hard. Now, what about that hardness do we care about? Well, we want to make sure that we install these with absolutely crystal clear, clean hands, right? Because any oil we get on this porcelain creates a path for electricity to flow because oil is a hydrocarbon, carbon is a conductor. But the most important thing is this thing is very delicate because it's made of glass pretty much. In fact, it's even harder than glass. So if we put any sideways torque on it or anything like that, it's going to break. And once it cracks, in comes the oil and you're going to have a bad spark plug in, 3,000 to 4,000 miles. Customer comeback, misfire, all kinds of problems. So we don't want that.
If that many miles.
If that many miles, sure. Yeah. Now, sometimes you'll hear it pop if you're doing it wrong. Many times you won't. And that's
Thursday now.
That's
What?
the part.
They've been going on Thursday, but
Now, let me draw.
they go. Well, my thing is that non-denominationals, I think they're a little.
Someone's got a microphone open. So that goes like that. There. So what we see is that we've got a steel rod that comes down from this tip of the spark plug to the center electrode. Which is this little piece right there. Right there. That piece right there. This thing right here is called the side electrode. And this part between the two is called the spark plug gap. That's where, when the voltage comes down here, because remember the side electrode is grounded, when the voltage comes down this way, it's going to jump across the spark plug gap if the voltage is high enough. So we got to make sure the voltage gets high enough. How do we do that? We use a transformer, right? Step up transformer. We're going from 12 volts to about probably 48,000 volts. Step up transformer. That we call it the ignition coil, but it's really a transformer. Okay, so I wonder if I can fit this on this page. I guess I shouldn't even try. Go to the next page. You got that?
Don't try. Just go to the next page.
Yeah, you got that?
Yes.
Can I go? Thank you. All right. This goes like that, like that.
You gotta lower the page.
Absolutely. Thank you. There we go. That's the side electrode. This is the center electrode. What's an electrode? It's just something that carries electricity. Now, this is called la apertura. Where's Joel Rivera? What in the world? That's called the spark plug gap, apertura. And the gap is defined as the distance from the center electrode to the side electrode. Does that matter? Yeah, that's freaking huge. That matters more than everything. Why? Because if we want an 8-cylinder engine to run like 8 cylinders that are exactly the same, which we do, we got to make sure that the spark plug gap is the same on every plug. Now, they're going to tell you at the parts store, the guy making minimum wage is going to tell you that they're already pre-gapped and you don't need to gap them. Don't listen. Now, what tool do we use to set that spark plug gap? One of my favorite drawings, so I guess I'll just thrill you with another version of it. Looks
Feeler
like
gauge?
this.
A gapping tool
Oh,
or a
okay.
feeler gauge.
How about a feeler gauge? Yeah, that'd be better. Yeah, that's called a feeler gauge. And it's going to say on it 0.045 inches or 1.1 millimeters. Because that's the same measurement. Now, you can get these for like $3 or $4 down at Harbor Freight. I strongly suggest it because you'll probably end up needing them more than once. And this is the exact way to do it. Now you say, well, I don't know if I trust Chinese freaking micrometers. Well, you should. It's not like they're hard to make. Chinese feeler gauges, you should. It's not like they're hard or complicated to make, right? I mean, if you can make anything, you can probably make a set of feeler gauges. So I've never had a problem with them. You know, run them all day long.
Don't they
this
make them in a form of a circle also?
Yeah, don't use that.
No?
Yeah, that's absolutely unacceptable way of doing it because it's a wedge, right? It's not two parallel surfaces, it's a wedge. So the question is, which surface are you going to trust? You know, this one, or, you know, lay it flat and do it this way. There's not enough certainty in terms of precision. Besides, you know, they gave you that in a set of screwdrivers with your, when you bought a Craftsman set of, you know, $10 screwdrivers. Don't use it. Feeler gauges, yeah. sometime when you're driving past Harbor Freight, just stop in there. Did you guys notice that Harbor Freight doesn't do 20% off coupons anymore? They don't. And you can't find them anywhere on the web. So
They
they've
cut them
changed.
all off.
Yeah, they've changed.
Moving
So,
on.
so a guy hit me up today, said he wanted me to come down to the school and let him borrow a scan tool to erase some codes. I'm like, dude, look, go on Amazon, $56. You can get the Kizyi, what is it, the 301 or something, TC 301 or something like that. And that way I don't have to drive down there and take 2 hours and blah, blah, blah. And it's like, okay, for $55, you really want to drive 15 miles each direction? That doesn't make any sense. So besides, everybody should have a scan tool, right? So that's what I'm going to tell everybody. I guess it's recorded now. So this is called a feeler gauge. And the reason it's called a feeler gauge is because you're supposed to feel a slight drag. You're supposed to put this between the side electrode and the center electrode, and you're supposed, center electrode, side electrode. You're supposed to put the feeler gauge between the two and pull it, and you should feel a slight drag. Feel a slight drag resistance as you pull the feeler gauge. Now, if you don't feel a slight drag, you need to close up that gap. If you can't even fit the feeler gauge in there, you need to open up the gap a little bit. Yeah, but whatever we do, before we install spark plugs, we need to make sure that they are A, gapped, and B, carefully installed, because carelessness in installation can cause all kinds of problems that we want to make sure to avoid. Yeah, so this is one of those things where you have to do it right, and you have to do it fastidiously, you know, using the right tools, etc. Now, maybe me, Chuck, or Rudy could get away with doing some hack job without the right tools, but that's only because we've been doing it for 30 years. So that's not you. So don't do it that way. So I'm going to show you the right way to do it, but first I'm going to talk about the spark plug.
Right way the first time, every time.
First, I'm going to talk about the spark plug gap. The old standard was this. That's tenths, hundredths, thousandths. So that's 35 thousandths of an inch. Yeah, because we measure inches in thousandths. Okay, that's tenths, hundredths, thousandths. So it's 35 thousandths of an inch. That's the old standard that every vehicle up to about 1971 used. And that's what we used with conventional ignitions, you know, breaker points. Okay, so what happened? Well, with the introduction of all these Asian imports and with increased emission standards, what we started doing is the manufacturers started increasing the size of the gap. And we went from 45 thousandths to 60 thousandths to 80 thousandths. And there was even a Cadillac that came out with 100 thousandths of spark plug gap, which is 1/10 of an inch. It was huge. Okay, well, first of all, what do you need to do if you keep increasing the gap size? You're going to have to keep kicking up the voltage in order to get the arc to jump across. Just like if a fireman is trying to put out a fire in a first-story building, he doesn't need that much pressure. Okay, what about the second-story building? Well, to get to the second-story building, he's going to have to increase the pressure. That's why the fire truck has a pump on it, a big old industrial pump. And if they want to get to the third story, they're going to have to increase the pressure even more, right? We keep on kicking the pressure up, and the water keeps pushing further away from the hose. Well, that's the same thing that goes on with voltage when it comes to jumping across this gap, because that gap is an insulator. Now, in order to get voltage to jump across an insulator, you got to have tons of voltage, because basically it's making a little lightning bolt across. So as a result, as we went up on the spark plug gaps, we had to kick up the voltage on our ignition systems. And that's why you begin to see things like high energy ignitions, GM's coming out, what, 75, something like that. You see the distributor caps went from this big to this big as we had to keep all the parts away from each other so they didn't arc and interact. And eventually you end up seeing stuff like distributorless ignition where the thing will throw a freaking arc like 1.5 inches. That takes a lot of voltage to throw an arc 1.5 inches. And again, we're creating little lightning storms in our ignition system. So what happened was, though, as we went to these super wide spark plug gaps, we found out that we were starting to have a problem as these things aged. And the problem was that as this thing operates, you're going to get pitting, which means as we have electrical transfer in one direction, we got material transfer in the other direction. So every time an arc comes this way, a little chunk of metal comes out. Okay, so do that for 35,000 miles. Do that for 30,000 miles. And what happens is, if you've seen an old spark plug, it looks like this. The center electrode's all rounded off, and so is the side electrode. They get rounded off, and they get like a scale on top of them. Well, I guess it is scale on top of them, which increases the resistance. Okay, well, let me ask you a question. If you increase the resistance hard enough, what happens to your ability to jump that gap?
It goes down because you no longer have the same voltage to jump.
Well, you got the same voltage, but you got way more resistance. Yeah. So it's equivalent of having a gap that's way bigger. As a result, what happens? Now the voltage won't go across the gap. Now the voltage goes somewhere else, which is bad. But the worst part is, if we don't have voltage across this spark plug gap, you have no arc. If you have no arc, you have no combustion. If you have no combustion, you're just dumping raw fuel straight into the catalytic converter. And people were driving like that for 15,000 miles, because remember, this is before OBD1. People would drive like that for 10 or 15,000 miles until they got their tax return so they could go get their car fixed. And as a result, what was happening is completely destroying the catalytic converters. Then they get really angry. But, you know, they're Cadillac owners, so they had a lot of money anyway. If they could afford an $8,000 car, they must be rich, right? Speaking of inflation, did you notice that the price of gas has gone up 20% in the last month? Yeah, I'm seeing it over $4 all over the place, and it was like $3.30. So I'll bet you it's way more than 20% by now. Inflation, when you see inflation, folks, it's time to start taking seriously the financial situation. Yeah. Start buying assets, right? Quack. I was going to say, especially brass and lead, but that was a joke. Joke. JK, just kidding. So my point was that the manufacturers pretty much all came back to 45,000 7-inch. And that's where pretty much everybody is now. They might say 44, but I don't think there's going to be any significant difference between those. Now, that also equals 1.1 millimeter, right? Two small m's, that's a millimeter. That's the metric equivalent of this, which is standard inches. Whatever the case, folks, you need to check your spark plug gap, because that's a big deal. And if you have 7 plugs that are exactly the same, but one spark plug gap that is smaller than the rest, that cylinder, no matter what you do, that cylinder is never, ever, ever going to work the same as the other ones, which means your engine's always going to run rough. It's going to be out of balance, not out of balance mechanically, but out of balance performance-wise. And, you know, the computer's not going to be able to compensate for that, no matter how powerful the computer is, because you screwed up in your installation of a basic fundamental part. Now, look, folks, spark plugs last 100,000 miles now. Why? Primarily precise fuel control. Also, you know, platinum tips, stuff like that, but primarily precise fuel control. So spark plugs last 100,000 miles, which means if you change the spark plugs in whatever vehicle you have right now, chances are good you'll never change them again, because most people are not going to have their cars for 100,000 miles. So if you're going to do it once, do it right. Yeah, do it right.
Except for Rudy.
Yeah, quack. So do it right. Incidentally, I got the Suburban running again, and then I drove it. I left it running for like an hour, and the radiator didn't leak. I was like, "What the hell?" It's crazy mechanical stuff, you know. Anyway, I got the new radiator, so. So now the battery was absolutely completely dead. What's the only thing that drains batteries, folks? Current flow, right? Current flow for what? I don't know. Maybe the computers. If something isn't wrong, like maybe the glove box got left open or something like that, what drains the battery? I don't know. The computer's constantly draining the battery to keep the clock correct, right? And keep the radio presets. for instance. Okay, so the battery is completely dead, so I hooked it up to a charger. Well, if you're charging 10 amps on a dead battery, it could take a long time to charge that battery. So finally what I did was, I said, you know, if I can get this vehicle started, I can let the alternator charge this battery and it'll do it at freaking 70, 80 amps. So it'll get done quick. So I got in there, actually started, and I just ran the engine for close to an hour. Why not? I haven't run the vehicle in what, 2 months now, which means I got to get rid of that old gas, right?
Yep.
I want to warm it up, make sure the transmission's warmed up, right? So it gives a chance to get rid of all the condensation in the oil and in the fluid. And I just let it run, and I watched the voltage go from 14 and something down to 13 and something. And it's like, okay, then the battery's charged, right? Now, you tell me how much it would have cost to get that car started if I didn't know anything about cars. I'd have to have it towed to a shop. There's Mr. Rivera. I wonder if he's been working late. I would have had it towed to a shop. Diagnostic charges $120 an hour. Maybe they say it just needs a battery charge. Maybe they don't. Maybe they have a shop that like Flintstone. Right? If I've got an honest mechanic, you'd say, well, it just needs a jump. Maybe call Auto Club, whatever. But if I had taken it to a shop, it would have cost me a tow, and it would have cost me $120 an hour diagnostic time. And who knows if they're honest? Who knows if they're going to tell me, oh, your starter's bad or your freaking injector need injectors? Because if I don't know nothing about cars, I'm just a big old freaking sucker. All right, so this is a feeler gauge. That is the spark plug gap. What can I tell you? When we're installing spark plugs, that was poor placement. Move this up on the page next to this if you can. I've got my ratchet right there. I've got my spark plug socket right there. And this right here's my ratchet. Hey, Joel, how are you? Missed you. We were wondering where you were. Hope you're late for making all that money. All right, so this is a ratchet. That's an extension, 3-inch extension, and that's your spark plug socket right down there. Okay, how do you install a spark plug? Insanely carefully, like you're transferring jewels, because really you are. Porcelain is probably the next hardest thing to freaking diamond, well, that will touch. Okay, but it's not strong like diamond, it'll chip. More like sapphire. Anyway, my point was that when we install these, we're going to put one hand here, one hand here. One hand holds this straight up and down, absolutely straight up and down. So all I'm doing with this hand is I'm making sure that it stays directly above this, and then this hand does the pulling. So it's a two-hand job. Now, if you can't do it with two hands, you better find someone that can do it with one, because most people are going to do it wrong and they're going to break the porcelain installing it, which means you'll be worse off than if you had just left the spark plugs in there. Why? Remind me why? Why do the manufacturers want to make it so it's 100,000 miles before a tune-up, or 100,000 miles before anybody touches the car? Because most of the time, if somebody touches the car, they're going to freaking screw it up. Most of the time. So they designed the car so that you don't have to touch the engine for 100,000 miles, because they don't want you touching it. Because if you touch it, you'll probably do something stupid. That's, you know, because people think they know how to fix cars because they, you know, because their dad showed them how to change the spark plug on a lawnmower. Well, it's a little more complicated than that. Yeah, in fact, this guy that ended up hitting me up for the scan tool, he was like, well, you know, I've got this 2003 Mercedes and it needs a head gasket, and I wondered if you wanted a project car. I'm like, I don't teach that anymore. I don't teach freaking engine surgery anymore. I don't teach people how to do minimum wage jobs, right? Because, you know, there's 3 times as many parts on a car now as there were back in the 80s when I took auto, 70s when I took auto. There's 3 times as many parts on the car. Okay, so you have to pick and choose what you teach. And, you know, I can't, that kind of work is done by people that make minimum wage now. Okay, so why would I train people to make minimum wage? They probably they're already qualified to make that. Yeah. That kind of stuff is usually done by people that make minimum wage. Why? Because if you had a qualified person do that, it would cost you $1,500 to change head gaskets. Unless you had some serious connects, like downtown in LA serious connects, anyway, my point was it would cost a lot. Now, is it that complicated of a job? No, but okay, anyone who's got the skills to do that kind of job would much rather be doing scan tool diagnostics, and would probably be doing scan tool diagnostics because it's much more profitable. That's a very labor intensive job. I just don't teach that anymore. I don't have time. Look at all the material I got to cover. It's insane the amount of material I got to cover. I mean, I'm not complaining, but it's just, back in the old days, we used to take apart starters and alternators and put them back together. No, you should not be teaching like that anymore. This is way too late in the.
I have a question with spark plugs.
Yeah.
So when installing a spark plug, can you start it off like hand tight first and then put or it has to be on
have
the
to,
ratchet
dude. Yeah, you have to. In fact,
you just screw it on hand tight first, then you put the ratchet on it and tighten it up. But you're saying you have
to be
super careful with it. So is the super careful while you're tightening it up and making sure that it's going vertical
that's tightening.
Cross thread? Is that what the whole?
Absolutely.
To prevent it from cross threading, right?
Yeah. Well, no, it's to keep the porcelain from breaking. Cross threading is something different. That's what we're going to talk about next.
Okay. So why would porcelain break though?
What? The porcelain.
Why would it break?
Because you put sideways thrust on it. See, the reason I hold it like this is so when I turn it, it doesn't put sideways thrust on the porcelain. If I hold my ratchet like this, when I turn it, it's going to go, and that's going to put force on the porcelain, which is just going to snap because it's hard, it's not strong. So I'm going to be up here just like a diamond, like I'm adjusting the Queen's watch. All right, this thing right there, that's a spark plug socket. And there's important stuff you need to know about the spark plug socket. First of all, there's a bunch of different, there's a couple of different sizes. But inside the spark plug socket, it's going to have this little rubber sleeve. And it's important that you understand what that rubber sleeve is and is not. But most people mistake that for what it is. Boy, what a great drawing that is. You would think after 30 years I'd know how to draw things. Okay, so that's a spark plug socket. This part up here is so you can use a wrench or another socket. But there's a little rubber thing in here. What's that rubber thing for? It's not so you can use one hand when you tighten this. It's merely
to hold the spark plug while you insert it.
Yeah. So when it gets all worn out and old, what do? Go buy another spark plug socket. They're only like $2. There's usually, okay, for cars, it's 5/8 and 13/16 usually. But this little rubber thing does not mean that you can just do a one-hander on it, because rubber, I don't know if you know, but when rubber gets compressed, it gets freaking hard as hell. And what it'll do is if you put enough pressure on the side of this rubber, it will quit compressing. And when it does, it's going to put all the force on the side of that spark plug and it's going to break the porcelain. Now you're screwed. Okay, because now what are you going to do? You're going to have to go all the way back down to the parts store and buy one spark plug. If you're lucky and you hear it, which you probably won't, which just means it's going to break, and now it could never work, or it could work for 500 miles, or it could work for 5,000 miles. You don't know. But whatever it is, you just screwed up something that you were supposed to fix, which is bad. So I think changing spark plugs is a kind of hardcore activity, especially these days. I mean, you're going into aluminum heads, and what Gabe was talking about, this cross-threading thing is an insane danger on aluminum heads. Plus, let me ask you a question. I told you don't take spark plugs out when you're hot. Now, if you take your car in for a tune-up, what are they going to do? they're going to pull those spark plugs. If that freaking engine's on fire, they're going to pull the spark plugs out. And if you look at the steel threads of the spark plug, it's going to have little bitty tiny silver balls, which are aluminum balls, which used to be your cylinder head threads. Okay, so if you do that enough times, what's going to happen? Eventually, you're going to screw in a spark plug. When it's your turn to change the spark plugs, you're going to screw in the spark plug and you're going to go to tighten it, and it's just going to keep on turning. Now you're freaking screwed because you blew the threads out of the head. Now you got to do thread repair on that, which is a big freaking deal. Big freaking deal. And now you've turned a freaking 20-minute job into a 3 or 4 hour job, especially since most of you would just have to go out and buy the tool and the inserts. I think I showed you that kit. Yeah, it takes, right, Chuck? We don't use freaking helicoils. No, don't use helicoils. We use time certs. Time certs does a great job on that, and it comes out bitching, and it stays bitching forever. Stainless steel threads stays bitching forever, and you never have to worry about, oh, is it going too far in the combustion chamber or something like? Nah, don't worry about it. Time certs, I'm telling you.
May I say something?
Yes, please.
Some of the new cars use a 14-millimeter socket now.
Mm-hmm. Yep.
They've gone even smaller on the plugs.
Yep. Yep.
That's all.
Good, thank you. So that's what this rubber's for. It's not for you to lever against. It's just to hold the plug. Now, are we going to make sure that we don't get oil and grease all over the tip of the spark plug when we're installing it? Yeah, we are. Yeah, it's a big deal. You got to be careful about this stuff. And if you aren't the type to be careful, or if you're the type to get easily discouraged or cranky, or if you're in a bad mood, stay the hell away from the car, because this job needs to be done right. If you do it right, you're going to have a wonderful, reliable installation that lasts for 10 years. If you do it wrong, you're going to make a freaking nightmare out of a car that just needed, periodic maintenance, right? I came in, my car ran great. I just wanted the spark plugs changed because it was over 100,000 miles. Now my freaking car doesn't work right. Yeah, so do you think they're going to come back next time they need some automotive service? I don't think so. So anyways, that right there is the spark plug socket. Let's talk about cross-threading. All right, so here is, oh, God doggone it. Here is, it's a straight thread, so they're parallel. Goes like that. That's one hole. Here's another hole. Same hole, actually. So, how the spark plug needs to go in is like this. I don't spend too much time making details. Yes, you have made Santa very happy. See, because this is going straight down like that. That's great. Now remember, most cylinder heads these days are going to be aluminum. These threads are going to be steel. Steel versus aluminum. Steel will always kick its ass, especially the kind of aluminum they use to make heads, because it's not going to be like hardened. It's not going to be like 7076 or something. It's going to be soft aluminum. How do you know it's soft? Hit it with a hammer or a screwdriver, really. Okay, so what Gabe's talking about is called cross-threading. And I'm going to exaggerate it a little bit just so you get the flavor. Now, is it going to look this exaggerated? Probably not. Or people wouldn't do it. But this is called cross-threading. See, this thing is going this way, but the hole is going that way. That's no good. And this is the #1 thing you got to watch out for when it comes to installing spark plugs. This is the #1 screw up people make, because cross-threading is super easy on aluminum heads, especially when they're hot. But it's super easy on aluminum heads because you got a steel thread going into aluminum. But what happens? You turn this in with a ratchet and it'll go about halfway and get stuck. Now you know you've made a horrible mistake. Now look, top view. Here's my cylinder head. All 4 spark plugs should be facing the same direction. Now, maybe they don't face the same direction because these 2 go like this and these 2 go like that, but whatever it is, it needs to be symmetrical. So if you've got 3 of them going this way and one, well, if you got, that's a perfect example. If you got 3 of them going this way and this one's going that way, you're probably cross-threading, right? Because symmetry tends to be symmetrical, the same. Symmetry, sim is same, metry is measure. Wow, he went to college. How should spark plugs last after you change them? On a modern car, 100,000 miles. 100,000 miles. It used to be like 30 or 40. But remember, we got much more precise fuel control, which pretty much doubled their length, their longevity. Plus, we've got, you know, like platinum plugs or something like that. It's really increased the longevity of these spark plugs. And pretty much 100,000 miles. Okay, questions? Comments? Yeah, you bet. You bet, man. Okay. Okay, now the question is which plugs, and here's the number one thing you need to understand.
Page down.
Thank you. They are paying people with PhDs in mechanical engineering from prestigious universities millions of dollars to determine what spark plug to put in. So if some freaking jackass who didn't graduate high school works out of his goddamn garage, if he's going to tell you that you should use a different spark plug, you know what you should do? Swipe left. Is that right? I don't know. Whatever you should do is not listen, because that guy's a freaking idiot. All these people think they know better. No, 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 no. No. Okay, so let's go back to our study of manufacturer families. If you have a General Motors car, that would be Chevrolet, Buick, Olds, Pontiac, Cadillac, General, GMC, Saturn, Hummer, whatever. It's going to have AC Delco plugs. I'm going to tell you, don't ever use any plug that the manufacturer doesn't suggest for that specific vehicle. Don't. And I'll tell you why in a minute. FOMOCO is Ford Motor Company. That's Ford Lincoln Mercury.
Motorcraft.
Is going to have Motorcraft or Autolite. And don't ever put a freaking AC Delco plug in a Ford or vice versa. Okay, so Mopar. Now this is interesting, and I wanted to see if any of you guys had any information on this. Mopar now is Fiat Chrysler, so they're owned by a European manufacturer. Back in the day, Mopars would come with either Mopar plugs or they would come with Champions. My question to you is, since they're now owned by a European manufacturer,
They run Bosch.
Are they running Bosch now?
Yep, most of them are running Bosch now.
Thank you, sir. That's what I suspected. Okay.
Well, that happened when Mercedes took over Chrysler.
Yeah.
They switched them over to Bosch because they claimed that the Bosch plugs were so much better than the Champion plugs.
Yeah, of course. Yeah. Yeah, Germans are the best at everything except winning wars. I think we proved that twice. Never mind. The point I was trying to make was, yeah, now I get like all this. Yeah, I get a suspension from YouTube because it's hate speech. Love you, Germany. Love what you've done with the place. So if you have a European car that's going to have Bosch spark plugs, and if you have an Asian car, it's going to have NGK or Nippon Denso. Now, I believe that Toyota bought Bosch, which is
Some
why
of your Saturns run NGKs too because they're running the Honda CRV motor in them.
I didn't hear you.
Am I off mute? Okay. Some of the Saturns run NGKs in them because they run the Honda CRV motor in it.
Yeah, that's the only good part of it. Except the gas cap. The point I was trying to make was, how old is the newest Saturn? 86?
No, the newest, the last year of Saturn was 20, I think it was either 16 or 17.
No, really?
Yeah.
Huh. I never would have guessed that. Okay, so here's the thing. Only use the plug that the manufacturer specifies. Don't ever cross-reference. And by cross-reference, I mean put a AC Delco plug in a Ford, or put a NGK plug in a GM, or an AC Delco plug in a Land Rover. That's called cross-referencing, because allegedly these plugs are the same. Well, I've been around the block 98 times, right? And I've tried to do this cross-reference thing, and all you have to do is pull out the correct plug out of the engine and put it next to the plug that they say is the exact same thing, and you're going to find out it isn't. And if these spark plugs don't look the same, they couldn't possibly perform the same. So only put in the exact plug that the factory specifies, because when it comes to engine performance, there could be a million causes of any problem, but I want to know for damn sure that it's not the spark plugs, at least. And you don't know how many cars we fixed just by putting the right spark plugs in it, because some jackass said, well, it's okay, put your auto light plug inside your freaking Nissan.
Or like the Jimmy with the platinum and iraniums that the Jimmy hated, but the minute you put coppers in it, it ran perfectly fine.
Right, sure. Okay, so that's called cross-referencing. Don't do it. Okay, so where are you going to find out which plug does it take?
Your
Well,
manual or whatever.
Owner's manual.
Yeah,
That's the best place.
Yeah.
But most used cars will not have an owner's manual. Okay, second best place is Pro Service Information, because I tried looking it up today in front of the students, and I was like, they gave you 18 million answers. Okay, number 3 is Parts Supplier, but you're going to get in trouble there, because what they're going to want to do is, let's say they get auto light plugs for half the price of NGKs. You know what they're going to do when you ask for spark plugs for your Nissan? They're going to try to sell you auto lights. So you got to watch out for parts suppliers, because first of all, they're, most of them are, many of them, I should say, are working for minimum wage, right? They probably never even took an auto class. All they know is how to, press buttons on a computer. So it's not like they're automotive experts. Now, if you can find a good parts person, that's a blessing from heaven, and you need to take care of them. But that's rare. That's rare. Number 4 is the internet, and you got to watch out, because internet forums spread all kinds of lies. I mean, if you sit and watch an automotive video with me, I'm going to be like, no, that's not right. I mean, just the Bosch video on direct injection had 3 or 4 significant errors in it. Okay, well, if that's what the manufacturer's putting out, what do you think some freaking jackass with no training is going to put out? You got to watch out. So the forums is probably the last place I would go, because you can't really rely on the information. Now, let me show you, because I know you guys love Rock Auto so much. Are you with me? I mean, am I going too fast?
Nope.
Okay, so let's go here, and let me show you what I found today when I just did this once. Come on. Okay, look. I have a 2008 Toyota Corolla with a 1.8 liter inline engine. Now, what spark plug does it take? Can you see that? Well, here's the auto light. Here's a Champion. Here's a Denso. Here's an AC Delco. Here's a Champion. Here's an NGK. Here's another NGK. Here's another Champion. You see they've got 3 different Champions that they say fit this car, and they're 3 different part numbers. How can that be?
Yeah.
If they were exact same plugs, why would they have 3 separate part numbers? They've got 2 different NGKs. One's a 2382, one's a 6953. Okay, one's standard, one's V-Power. Okay, that makes sense. But they got 3 different champions. Okay, they got a 711, a 71, and a 71G. What the hell? Okay, now that's just copper plugs. Now we go to platinum. And you can see we got Autolite Champion, NGK, Denso, Bosch, AC Delco, and Motorcraft. So it's got Autolite and Motorcraft. So those are the platinum plugs. And then we go to iridium. Okay, so that's 4 times as long as copper. And now we've got a whole bunch of 2 different Denso numbers, 5303 and 4701. Oh, 3324. So now it's got 3 Nippon Denso numbers for the same engine. Explain that to me, because I guess I'm too stupid to understand. And then it goes double platinum. Oh, okay, so now we got a whole bunch more numbers. You know, a ruthenium, what the hell? $8 for a spark plug? I don't know, whatever. Anyway, the point I was trying to make was, rather than trying to figure out which one of these, rather than guessing and hoping that maybe it's the same plug, you know what I'm going to do? I'm going to look on the owner's manual. Sometimes there's going to be a sticker on the radiator support. The emissions sticker is going to have the part number of the spark plug. That's primarily Asian imports, though. But you know what I'm going to do? I'm going to make sure I use the factory plug, because then at least I know, I don't know nothing about this engine except I know the spark plugs are right, and I know that they're installed correctly. And that's huge. That's huge. That means I don't have to take them out and check them, which is huge, because taking out spark plugs, that's a serious job. Now a professional can get it done quick. And if you know it's an inline 4 and the spark plugs are right on top, it's easy to get it done quickly. But to do it right requires special tools like feeler gauges, for instance, and a special technique, which most people don't have. And I'll bet you if you watched YouTube videos on changing spark plugs, you probably wouldn't see 10% that told you that little thing I told you about holding the ratchet while you turn it with the other hand. And I'll bet you even less, I'll bet you probably 90% of them are going to tell you, well, these spark plugs are already gapped. You don't have to check it. No, huge mistake. What if they drop the box? Now, there's some plugs you can't check the gap on, but if you can check the gap on this plug, you need to check the gap on it. It's like using it's worse than using a torque wrench, because if you have one spark plug gap that's different from all the rest, that cylinder, there's no fix for that cylinder other than taking out the plug and doing it right this time. So this is huge, but I wanted to show you this because it's a perfect example. Use the right freaking plug. Now, I came over here to Beautiful Protoman, which something tells me we're going to be using a lot more. And it says right here, log in. Okay, so log in. And I've got, you know, if you want, I'll just use the exact same car. Use a 2008 Toyota. What was it, Corolla? Ah, crap, I don't know. It's probably a CE. Automatic trans. Let's use that vehicle. And I'm going to say spark plug. Okay, spark plug right there. Okay, specificaciones. Recommended spark plug. Well, there's the Denso and there's the NGK. That's the 2 plugs you should use. Don't use anything else, because if you do, it's going to make you cry at some point. If not the first time, it'll catch up to you. You believe it, Chuck? What do you believe? Chuck, do you believe
Your word is the gospel truth.
Yeah. Now, here's the thing. They're always going to try to upsell you to platinum plugs because they have higher durability. If your car didn't come with platinum plugs, I do not suggest putting the platinum plugs in it. Why? Because they glue a little chunk of platinum to the electrode. Okay, so you know how many times I've pulled plugs out and they didn't have that little chunk of platinum anymore? Okay, so now what happens to your car? Now you got some weird running or a misfire, something like that. I don't trust them. If your car came with platinum plugs, you put the exact plug in that came out of it. If it didn't come with platinum plugs, I don't really suggest running them. Now, what Rudy say? I sold him a Jimmy, GMC Jimmy, what is a 79? And it had platinum plugs in it and ran like crap. We put in copper plugs and it worked good. I suspect the platinum plugs probably had some problem with them, like the little chunk of platinum came off. It happens all the time.
It kept fouling out one plug.
Yeah, that'll do it.
Every time I put new plugs in the thing, it would foul out the one plug. And then I put the coppers in and never fouled it out again.
Boy, I don't understand that. Okay, so anyways,
Don't have a clue.
yeah, that's the correct plugs, folks. Don't use nothing else, right? It's a Toyota and it uses Denso and NGK. That makes sense. Don't use nothing else. I'm tired of fighting it, folks. I mean, this is stuff that I've learned over 40 years of fighting it. So I don't fight it anymore. In fact, on an aluminum head, you got a long thread on the spark plug because it's going into a softer material, so we need more threads. On a cast iron head, you got short threads because it's going into cast iron, which is very strong. I don't think you'll ever strip out a cast iron spark plug thread. I've never done it. I've never seen it done, unless you put it in with a freaking impact, I guess. Anyways, my point was, I've seen the cross-reference work out such that the spark plug that was supposed to have a short thread, they gave us a long thread. If I hadn't been there, they would have plugged that freaking long thread spark plug in where that short thread spark plug is. Okay, where do you think those threads go? Those threads go into the combustion chamber, you know, right where the piston is. So all you need to do is have a spark plug thread sticking out into the combustion chamber, which is an absolute no-no. And then you got the piston coming up, hitting that freaking spark plug, destroy your engine. Why? Were you trying to save $1? Because you trusted some parts jackass? So I saw that with my own eyes. And if it hadn't been for me getting lucky and seeing that, the students would have installed it, right? Because they wouldn't know. So I've changed what I focus on in this lesson because of what I've seen that scares me. Oh, shoot, it's 7:31. So 15-minute break?
Okay,
Yeah, don't be late because
okay.
we got tons of stuff we got to cover so we can get back in the shop.
Hey, Michelle,
Yeah,
I missed that conversation about disabling your truck.
Okay. What the hell? The thread's not above that. God, I'm smoking crack. Okay, never mind. Stupid. Anyways, the thread is below. Thank you kindly. It's all right that nobody caught that except me. I guess I get to teach the class still. Just lost faith. Okay, so there's a spark
We're
plug.
just giving you a chance to catch it.
Yeah, didn't want to shame me. All right, so this goes like that, and this goes like this. Dumb. Okay, so anyways, my point was, this thing right here is called a bevel, which just means a taper or a angle. This thing right here is a washer. Two types of sealing systems for spark plugs. This is a crush washer. It's made of aluminum. Come on, David Burks, let's go. David Burks keeps dropping out. That's tough. Okay, so this is a bevel. This is a washer. This washer is made of aluminum, which is very soft. We absolutely need this spark plug to seal. Absolutely. Or we'll lose compression pressure, we'll lose combustion pressure. So as I say, tightening spark plugs to me is like a big deal, a serious deal. So when we tighten the spark plug, we need to crush the washer. So it needs to be compressed. Okay, well, that means we're going to have to turn this a bunch of turns after this washer makes contact with the surface that it rose up against. Not a lot of turns, but we're going to have to turn it a lot, like maybe a quarter of a turn. I don't know. Don't quote me on that, but maybe close to a quarter of a turn. Over here, this is a bevel. You can't turn this a quarter of a turn after it meets its match. You can turn it maybe an eighth of a turn, but that would be pushing it, I think. We're supposed to use a torque wrench when we do our spark plugs, folks. Anybody got a torque wrench that goes down that low? Because that's going to be inch pounds. Most of us, if we have a torque wrench at all, we have a foot-pound torque wrench. Yeah, I got plenty of foot-pound torque wrenches. Mostly I have like kilogram per deciliter torque wrenches. Rudy, you got a snap-on torque wrench?
Yes, I do. You gave it to me
And you still got it though. That's the
back
thing.
in East LA.
And you still got it. That's the problem. Okay. So anyways, I got to do
Yes,
something with all
why
my,
wouldn't I have it? You gave it to me.
I got to do something with all my funky torque wrenches. Now, Gabriel Alvarado knows that the new National Electrical Code requires you need to have a torque wrench in order to make electrical connections at the panel. And if you don't have a torque wrench, the first thing the inspector is going to do when you replace the panel is they're going to say, okay, let me see your torque wrench. Because these connections have to be torqued. Because if they're too tight, it's going to cause problems. If they're too loose, it's going to cause way more problems. So they got to be set just right, because after all, you're going from copper into something that isn't copper. So we need to be very, very careful, especially, you might be using aluminum conductors. So you need a torque wrench. You got a torque wrench, Gabriel Alvarado?
Sir.
Oh, you're a good man. Really? Because back when I was teaching that, nobody had one. In fact, nobody knew what it looked like.
It's in the work truck.
So as a result, a bunch of crap burned down because, people were doing it wrong. So I'm glad to hear that. How long has it been since I taught electrical, Rudy? Like 10 years, 15 years? 10 years. Yeah, 10 years.
About that.
Yeah, about 10 years. Yep, that's funny. So anyways, the bevel, you're not going to be able to turn as much. So first of all, you need to know whether you got a bevel or a washer. But second of all, you need to use a torque wrench. And if you don't have a torque wrench, you need to be very, very careful. Because this is not something I would do with a 1/2 inch drive ratchet. 3/8 drive would be perfect. 1/4 inch drive, I think would be too small. But 3/8 drive is just about perfect for spark plug. So get yourself a good set of spark plug sockets. Fresh set, probably costs you what, $6, $8 for 2 of them. And they'd last you forever, the rest of your life anyway. We're probably not going to, unless we're doing, unless we're working in our driveway or working in a shop, we're not going to be doing a lot of spark plug changes, right? People used to change spark plugs regularly all the time, but back in those days, we were going into cast iron heads. It was pretty hard to do it wrong. Well, now it's really hard to do. Now it's pretty easy to do wrong, and it's hard to do right. So that's why, it used to be like the first job you'd teach somebody. Right now, I ain't going to teach nobody to do spark plugs unless they've proven that they can do a whole bunch of other stuff first, like use a torque wrench on the lug nuts. Okay, so that's my theory on that. What else do you need to know about spark plugs? What else do you need to know about spark plugs?
Real quick, Mr. Rowcliffe,
Sure.
You said that it's best to change the spark plugs while it's cold, not hot.
Got to. Do not change them when it's hot.
So like you need to let the engine cool down before you even, right? Okay.
Absolutely.
And you're saying that when you take it to a place, they don't take that precaution. They just go ahead and start working on it right away.
Oh, no. You'll be lucky if they don't use a 1/2 inch ratchet to a 1/2 inch impact to take them out and put them in.
Oh wow.
Because they're in a hurry, right?
Right.
So they don't care. And if they strip out the thread pulling it out, well, by God, when they turn it in there and it keeps spinning, they're going to say "Hey, threads are stripped. So that's an extra charge, right? They're not going to say threads are stripped because we're jackasses and we don't care about pulling spark plugs out of hot heads. People don't know that. Okay. How are you going to prove that it's their fault?
Right.
They're going to say it was that way when you brought it in.
Yeah. So, we learned this from Jiffy Lube, right? Because Jiffy Lube, that's like they have a canvas sleeve. Well, actually, it's probably asbestos sleeve that you put on so that when you're pulling oil out of this, you could drive it right in. Hell, I'm surprised they turned off the engine. That was a joke. But the oil's hot as hell. It's probably 300 degrees, and they got a sleeve in there so that they can take out the drain plug because they're going to drain it right away. They don't care. And the same thing's true with many places when it comes to spark plugs. If it's a tune-up place like that, a quick tune, they're going to pull the spark plugs out. They don't care how hot it is. Now, also, when the engine's hot as hell, taking out spark plugs is very, very painful, especially since you're going to have to get around most exhaust manifolds. So it's not even worth it. Let it cool overnight. If you're going to do it yourself, let it cool overnight, especially since on many vehicles, you have to go through all kinds of funky contortions to get the spark plugs out. On many vehicles, you have to take the top of the intake manifold off. So there's a lot involved. Now, let me give you a little
More
player's tip.
flex.
Yeah, let me give you a little player's tip. I mean, back in the old, what are they, Windstars? Or no, it was the Dodge Caravans. You had to go in from under the car to get the back plugs out. That's a trip, and that's not something you want to do lightly. Now, I'll give you a little player's tip on many rear-wheel drive V6s and V8s. You go in through the wheel well. And it's designed to go that way, like the old Camaros and Firebirds and such. So consider, at least when you're doing this kind of service, if you're struggling and you're running into problems, consider going in through the wheel well. Like, for instance, the MR2s, that's obvious. But consider going in through the wheel well. There's a bunch of stuff that only comes off through the wheel well. Like, for instance, like the alternator. Many of those bolts are near impossible to get, but if you go through the wheel well, it's easy.
Or if you're trying to pull the main pulley off of Acura Integra.
Right, sure,
Through the
absolutely.
well.
Yeah, there's no other way to do it that I'm aware of. Okay, incidentally, I'm missing one of the turn signals on the Z06. The connector must be loose on the front one, because sometimes it works and sometimes it doesn't. But I'm gonna have to go inside the wheel well, probably pull the wheel off.
When I come over to do the Suburban radiator, I'll take a look.
Well, hopefully we'll get back in the shop. So, well, damn, that's going to be like 5 weeks, right? Damn it. I was going to say, hopefully we get back on the shop. I can just have the kids do it. It's much easier with a lift. So, oh, incidentally, where are we supposed to put the alignment rack? I don't know. Chuck says ADAS system. Folks, we got to find some way of spending all this money or it's just going to go away. So, you know, put a second story on the auto shop. Well, I'll get a bunch of those trainers, but it's going to make it very crowded. But you know, even
about enclosing the outer yard, maybe.
Yeah, they're going to do that, and they're going to increase the lights, and they're going to put in that mini mesh around. It's going to be freaking groovy. Plus, they're going to extend the shed all the way to the wall, so it's going to be freaking groovy. But even, you know, when you're spending $5,000 at a time, it's really hard to spend $150,000. That's a lot of stuff. So poor me, first world problems. Anyway, the point I was trying to make was, Chuck says ADAS system. I'm not sure, but I went to the conference, and God knows there's nobody better at ADAS than Scott Brown right up the street, Montclair High School graduate. But yeah, I might end up having to. I don't know where I put all this stuff. You know, the shop's just getting so crowded. Anyways, the point, so that means I can get a good air conditioning machine. I already ordered the transmission flush and the fluid transfer and the coolant thing. So we're in good shape in that regard, but I don't know where I'm going to put it. Just to make you happy, Chuck, I got the coolant thing and I got the freaking oil flush just for you, buddy. And I got thermal cameras too.
Yay.
Yes, you got thermal cameras. Now, let me ask you a question. If I have a thermal camera, couldn't I look at an exhaust manifold, and shouldn't every part of the exhaust manifold where it bolts to the head, shouldn't they all look exactly the same?
Yes.
Signifying that they're all getting the same fuel
operating
mixture?
balance.
Yeah. Could you find a leaking injector with a thermal camera?
Yeah.
Yes.
A plug yeah, right? I'm kind of excited about that.
You find electrical shorts too, right?
Absolutely. Yeah, absolutely.
I can find.
Now, I watched that show Homes Inspection, and he's using a thermal camera to find water coming into the house. It's freaking cool, man. I'm starting. I like that show. I don't like many shows, but I like that show. Okay, so anyways, my point was that here's what we got to do. We got to come in here with B+, you know, battery positive, 12 volts. And then we got to come into a switch like that called the ignition switch. That's the thing you put the key in. Then we're going to come in here to another switch called a coil trigger, because that's what's going to get the coil to build a magnetic field, collapse a magnetic field, build a magnetic field, collapse a magnetic field. That's what we're doing with the coil primary. Remember, it's just a transformer. Got too excited. Chuck, I saw if Ranger makes a on-car brake lathe, I was thinking about, Ranger, not Ranger, Hunter, quack. Anyways, hope the Hunter guy isn't watching. Okay, so we got a coil like this. And it's going to be grounded over here. And then we got all kinds of windings over here because it's a step-up transformer. And then this comes over here to the sparkalito, right? We saw it draw Santa's hat. Come in here like this, come in here like that. That's it. This is the coil secondary. Why? Because that's where the energy is second. This is the coil primary. Why? Because that's where the energy is first. And the coil primary is going to give us 12, well, it's going to receive 12 volts. That's the low voltage side of the ignition system. Coil secondary, I don't know, maybe 40,000 volts, 40 kV. This is a step-up transformer, folks. This is why we studied electrical basics for so long, so that we can get through a lesson like this quick, because we already know what a transformer does. We already know how it acts. As current flows, close this switch, close this switch. Current flows through the primary. As the current flows, it builds a magnetic field. The magnetic lines of force of that magnetic field are going to interact with this coil and create current and voltage. Well, it's going to create voltage at least. Okay, can't create current until what happens is when we open up this coil trigger, this magnetic field collapses. Now there's all kinds of energy has been induced onto the secondary, and that energy wants to find a place to go. Well, as long as the lowest resistance path to ground is through this spark plug, down to the center electrode, across to the side electrode, we're going to get a spark. All that energy is going to go to creating this spark, because there's a little rod that goes from this tip to that tip. Steel rod, usually with a resistor in it so that it doesn't make noise on your radio. But that is the complete ignition system for a single cylinder engine. Now it's going to get more complicated, but we can handle that. Okay, so all it is switches. It's got an ignition switch to give the system power. It's got a coil trigger, which is going to tell basically it's going to tell the coil when to put out a spark, because when we close the switch, current's going to flow, build up a magnetic field. We open up the switch, magnetic field collapses, and all this energy is going to come down here at the spark plug wire, jump across the spark plug gap, and that's what's going to give us spark.
Yep.
All right, you got that? Can I move?
Yep.
Okay. Let's do this, and we want to do this pretty quickly, so don't put too much effort into making these spark plugs. Right, just like that, just like this. Leave probably 3/4 of an inch at the top of your page, please, because we're going to have to put some spark plug wires in it. That way, this is just spark plugs, whatever. They don't have to put a lot of detail in them because we don't have a lot of time. But we know that these are spark plugs. There's 4 of them. 4 little Santa hats, and the bottom goes like this. I'm going to say 1, 2, 3, 4. So that's the spark plugs, 4 cylinders, 1, 2, 3, and 4. Okay. Over here we have a big old circle, and it's got 1, 2, 3, 4, 5 circles inside it. That's a distributor cap, and that's what this is. That's a distributor cap. Now this is a little different than the one we drew, because this has got 1, 2, 3, 4 holes. But instead of having a center hole, it's got this little mechanism here, which is going to put the center hole is going to be that one right there. So instead of starting at the center, it's going to be over here. And if we were to look at the bottom of a distributor cap, we're going to see that each one of those towers, that's a tower, each one of those is going to have an electrode sticking out of it. And in the middle is a button with a spring that connects to this, which connects to the ignition coil, because this is a distributor. If we have multiple cylinders, we need to distribute the spark to each cylinder one at a time. All right, so what goes inside the distributor cap is a, let me kind of anticlimact it. There you go. Rotor. Why do they call it a rotor? They call it a rotor because it rotates. And as you see, you can see right here, is where it makes contact with this button, which is made of carbon, so it can spin. And then there's a circuit that goes from here to here. So I'm going to put this in upside down, but it's going to show you how the rotor works. See, it's going to connect this cylinder, this spark plug to the coil. Zap, sends voltage. This to the coil. Zap, sends voltage to the other spark plug. This connected to the coil, sends voltage to the third spark plug. And that's how the rotor works. It's on a shaft in the distributor called the distributor shaft, which is turning anytime the camshaft turns, because that's how we drive the distributor. So as a result, the rotor is always rotating. And what's happening is, as spark comes from the coil, it gets distributed to the individual cylinders by the rotor. You know how the freaking dude at the tire store tried to charge my wife $1,300 to repair her Suburban, and all it was a bad rotor? Freaking punk. Yep. Yeah. I said, did you check the pickup coil on that? Because it was getting no spark. I said, did you check the pickup coil on that? He said, no, you can't do that on this kind of distributor. I said, sure I can. You got a freaking meter? I'll show you how to do it. Freaking punk. So of course he bashed in the bottom of the radiator with a hammer. So we had to replace the radiator. Freaking double punk. What a freaking punk. Oh, it's good thing this is being recorded, or I'd tell you where it was. Anyway, it was in Laverne, so watch out. Anyway, so that's a distributor cap. They call it a distributor cap because it goes on top of the distributor. Yeah, just like a cylinder head goes on top of the cylinder. And when it's completed, it looks like that. This is for a Honda, so it mounts sideways. Okay, so I'm going to take this off for clarity. Now, look, this is the distributor. In here is where it hooks to the back of the camshaft. So single overhead cam. So when the camshaft spins, the distributor shaft spins. Now let me put the rotor on the distributor shaft. I'll show you that as I spin the shaft, the rotor spins as well. So the rotor is going to turn at camshaft speed. Now, something I just noticed, which is interesting, something that I noticed earlier this morning. Where's my flashlight? Doggone it. Well, I don't need it, sort of. It's right there. Okay. If you look right here, I took the rotor off. What do you see? You see this is a trigger wheel. And that right there is a pickup coil. We're very familiar with this setup, which is good because this thing's filled with it. Okay, this is what they use for a crankshaft position sensor. See, it's only got one wheel. It's only got one prong. So as I turn this shaft, the crankshaft position sensor, other way, crankshaft position sensor is going to turn. And every time it gets next to this pickup coil, you can see that metal part right there. It's going to say, hey, crankshaft is turning. Now, right, we're pretty good at trigger wheels by now, right? Okay, so look, it's got another one down here that looks like a trigger wheel, but I don't know what it could be triggering, but I do know one thing. And I wish I had my flashlight.
It looks like the trigger wheel is on the bottom.
Yeah, does okay, but now that's the trigger wheel for the coil primary. I agree.
Because there's four interrupters there.
Right, I agree. That's the one for the ignition, but I can't imagine why they would put what looks like a trigger wheel on top of that. I don't know what that's for, and I don't see, one. You would expect to see one tooth that looked different from all the others. It doesn't have that. So let me do this. Anything to teach auto, right? Make any sacrifice. There you go. Okay, so look. Chuck's exactly correct. if you, sorry, if you turn this shaft, you can see that there's at the very bottom, which is down here, at the very bottom, right there, underneath all these teeth right here that look like a gear. You know, I think what the light's doing is the light is making the,
It's casting a shadow.
there you go. You can see this big thing with all the teeth here. I don't know what it does, but I know the one below it. Ah. See, Chuck?
Oh, shit.
There we go. I know the one below it has 4 prongs. So as we turn it, those prongs are going to tell the coil, that's the coil trigger. And you say, well, that's not just a coil trigger, that's just a trigger wheel. Yeah, but see that black thing down there that's right next to it? That's where the pickup coil is. Now, here's the thing. What happens is this seal, the orange thing right there, this seal goes bad. And when it goes bad, oil comes in. And since oil is a conductor, it destroys the distributor. Now, you can get these distributors for like $400 from Honda, or you can pay like 50 bucks and get a Chinese one. Guess which one I'm suggesting you do? Get the cheap one, because you know if you got a car with a distributor anyway, it's not going to be around very long. Why spend the big money? And I've had good luck with the Chinese distributors. They cost like 50 bucks and it's shipped to your house. This is what Chinese distributor. And you look at all this technology, you're like, how the hell do they sell that for 50 bucks? I don't know. I don't care as long as it makes the car run. So,
Mr. Roecliffe,
yes, sir.
you think that one triggers for the tack?
Could be.
Hmm.
Yeah, it very well could be. I mean, because you know, but that would mean they weren't using the crankshaft position sensor. But yeah, it makes sense it would be the tack because it doesn't have like one tooth missing or something like that. So it can't be used for the position of anything. So that's what the distributor looks on the inside. Now you say to me, okay, so you put the rotor on top, and the rotor is part of the secondary ignition system, right? Because it's taking the coil voltage and distributing it to the spark plugs. But the coil trigger is part of the primary. So is the distributor primary or secondary? It's both.
Oh,
It's primary at the bottom and it's secondary on the top. And we're going to find that out about the ignition coil too. Half of it is primary and half of it is secondary. The important thing is, do we know what primary and secondary refer to? Primary refers to the low voltage side, 12 volts. Secondary refers to the high voltage side, 40,000 volts. Big difference is 40,000 volts. We got to have all kinds of insulation to make sure that that electricity doesn't go someplace else, because we got enough voltage to jump across the air. If we're not fastidious about making sure that we've got our insulation in check, secondary ignition system is very likely to fail. In fact, spark plug wires are the #1 least reliable thing on an engine, period. So this is a distributor cap because it goes on top of the distributor. Remember, there's 4 types of ignition systems: breaker point, electronic ignition, distributorless, and coil on plug. Easy. That covers 120 years. This we used until 1970. So this lasted like 80 years. Why? Because it was mechanical. So this is a distributor cap. I'm going to say 1, 3, 4, 2. And you say,
They
that's
use
not
that
how you
longer
count.
than 70s.
Yeah.
Because they were
Sure.
still using distributor caps in the 90s.
Right. Okay. So you say 1, 3, 4, 2. That's not how we count. 1, 3, 4, 2. Yeah, it's not how we count. It's an order called firing order, because engines don't fire the spark plugs 1, 2, 3, 4, 5, 6. Well, one of them does, but it doesn't go 1, 2, 3, 4, 5, 6, 7, 8. And they hardly ever go 1, 2, 3, 4. Firing order is the order in which the cylinders fire, the spark plugs fire, which ain't going to be in numerical order. Say, for instance, on a small block Chevy, it's 1, 8, 4, 3, 6, 5, 7, 2. Right? Companion cylinders, whatever. Anyways, let's go ahead and draw the rotor, which is going to, in this case, be taking the coil energy and distributing it to the #1 spark plug. So there's the rotor, and I'm going to put my little arrow on it to signify that it turns, distributor speed. And I'm going to take my number 1 spark plug wire and I'm going to roll it over here, leaving as much room as I can here. I'm going to take my number 3 spark plug wire. I'm going to jump this wire and go to plug number 3. I've got my number 4 spark plug wire. I'm going to jump both of these wires and go all the way down to plug number 4. I'm going to take my number 2 spark plug wire and I'm going to jump this one and come over here to the number 2. Those are called spark plug wires, and they are absolutely the number 1 reliable failure, the number 1 unreliable thing in the engine. Anytime you have a problem with the car with the distributor, you should suspect the spark plug wires if it's got a cylinder issue. Okay, so those are the spark plug wires. They have to be very well insulated. They got to have big wires. It's not because they got big conductors. They got small conductors. In fact, they're not even wire, but they got big insulation, that's for sure, because we're talking about all kinds of voltage, you know, up to 40,000 volts. All right, you got that? Let's go ahead and draw old school conventional coil. Looks like this. And it's got this on one side, negative, and it's got this on the other side, positive. Coil comes like this. Try to make your drawings the same size and the same position on the paper, because we got lots to draw. While we're here, let's just come down here, put a battery, plus, minus, connect this to ground. And I'll have this video up, so if I'm going too fast, then you'll be able to finish your drawing. Okay, so this wire is going to come up to the ignition switch, just like we did before. This wire then is going to come and connect to the positive terminal of the coil primary. There's that, in case you're wondering. Now, coil primary. Here's the problem you're going to have with the ignition coil. Here's what an ignition coil looks like. This isn't the same type of ignition coil, but it's an ignition coil. And what it looks like is that this particular one has primary leads here and here. And then it has this thing which plugs into the coil wire. And this goes straight to the center of the distributor cap. So if we wanted, we could come over here with our black pens. Got a black pen? A black pen, and I don't care. Yeah, there we go. So I'm going to come out the top of the coil tower and go straight to the center of the distributor cap. And I'm going to call this the coil wire. It's also, remember, it's also part of the secondary. So it's going to need to be very well insulated, very well taken care of. Not oily or greasy for sure. Now, the problem you're going to have with this ignition coil is usually when we see a transformer, we're used to seeing two coils facing each other like this, you know, with an iron core between them. That's not how this works. This has the primary wrapped like this, and then inside it is the secondary wrapped really tight in a very small cylinder, so it fits inside. So now you got the primary on the outside and the secondary on the inside. It works the same, it's just a different method of construction. So what I'm going to do here is I'm going to come over here and I'm going to make big old loops like this, coil primary. And I'm going to come up and I'm going to connect to the negative side. So that's the coil primary, very similar to what we're used to. Here's where it's different. The coil secondary is going to come down here and it's going to be a million coils like that, right? Because we got to like increase the voltage by a factor of about 2,000. And then this is going to come up and also connect right here. So the red part is the primary and the black part is the secondary, and that's how the coil is built. So you get confused by looking at it, but it makes sense when you think of it that way. Okay, so now we've got every part of the ignition system except the coil trigger. And I've saved that for last because it's probably the most complicated part, but I think we're going to be able to get through electronic ignitions tonight. We have to trigger the coil somehow. We have to close the switch so that current will flow through the primary, inducing a voltage in the secondary. And then we have to open the switch and cause that magnetic field to collapse, which causes then a big burst of energy to go out the coil wire towards the distributor. So what we need to do here on the negative side of the coil, which is also the distributor side of the coil, the tack lead, if you want to hook up a tachometer, what we have to do is we have to figure some way so where we can build and collapse that magnetic field. So we're going to use a switch because after all, this is the first system, which is called breaker point. So it's going to have something that looks like a square, and it's going to be on the distributor shaft, just like the trigger wheels, because this was way before trigger wheels. That thing is called the rubbing block. And of course, this shaft goes up to the rotor like that. So they're both spinning at the same time, the same speed. And then what we're going to do is we're going to put a switch right here that's controlled by this rubbing block. You know, little contacts like that. It's hard to draw this because it kind of works the opposite of how you would expect. Oh, shoot. Okay, goes like that. So I got a little pair of contact points right there. And what it's going to do is it's going to complete the path to ground. When this is off the rubbing block, these points are going to close. They're called points because this is a breaker point ignition system. And we used it for 80 years. Because why? Because it breaks the circuit. As you can see, the coil trigger in this case is on the ground side of the primary, right? We've got 12 volts going to the coil all the time. What we're doing is we're interrupting or breaking the path to ground. And that's how this system operates. In case you're ever wondering, hopefully you'll never see this, but me and Chuck, I mean, this is what we grew up on. So when the
Me too.
Yeah, when this goes on the apex, which is to say the peak of the rubbing block, sorry, the breaker points are going to open. When it's off of that rubbing block, this drawing is not really accurate perfectly, the switch is going to close and we're going to get current flow through the primary. As soon as it opens, it's going to release a big old jolt of electricity down the coil wire, which is going to be taken by the rotor through the distributor cap and to each individual spark plug. That's how it works. Now, there is a video that you need to watch called Build a Taser by Electro Boom. You need to watch this video. Now, hopefully I'll get enough time I can show you a little snippet of it, but for our purposes, we only need to watch like a minute or so of it, not the whole thing. But if you have time, yeah, watch that. How to Build a Taser by Electro Boom. Just put taser and Electro Boom and it's going to take you right there. I think I've shown you this video 18 times, but it's good to see it again now that you see all of this. Okay, so what's the problem? Well, the problem is this is a mechanical thing and mechanical things wear out, right? Every time you have a spark, every cylinder, this thing is going to connect, reject, connect, open, close, open, close, open, close. Every time you have an electrical connection made or broken, you're going to have an arc. And that arc is going to, even though it's 12 volts, it's not going to be a big arc, but it's going to be an arc. And what that is going to do is it's going to tear a little piece of metal off every time you make or break that connection. which is why these things got pitted, they got corroded. And what happened was the adjustment would go bad. Rubbing block's going to wear, this little thing is going to wear, the things are going to pit, so they're going to get further apart. And that what that did was it changed the dwell, what's called the dwell, and that changed the timing on the engine, which means, and it retarded it. It didn't make it better, it made it worse. So what we would see is if you didn't adjust your points, what would happen is your car would just run worse and worse and worse until eventually it wouldn't run at all. So this was a regular maintenance item. We had to adjust these things like every 3 months. Unacceptable. Modern customers will not accept having to take your car to the freaking mechanic every 3 months. All right, now we're used to not changing plugs every 100,000 miles, but this was like take your car to a mechanic every 3 months. That's unacceptable. Way unacceptable. Because why? Because this is a mechanical switch and mechanical things wear. We got wear on the rubbing block. We got wear on this thing. We got wear on the points themselves. So we would have to come in. Well, when we got to my era, we just bought new points and installed them. But back in the olden days, we used to have this thing called a point file, and we would come in here and it would be all rounded off, just like I showed you with the electrodes. It would be all rounded off. And what we'd do is we would come in and we'd make it square again. That's how freaking jacked up this industry used to be. We would actually service points instead of replacing them. Yeah. Anyways, so yeah, we used to service spark plugs too, instead of replacing them. It's hard to believe we freaking lasted a minute. It's hard to believe it's hard to believe we won every war after World War II. Maybe I shouldn't say that, but the point I was trying to make was that this took an insane amount of time. Yeah, I mean, we used to do all the work of taking all the spark plugs out, and then we wouldn't put new ones in. We'd put in stuff that we had filed. It's crazy. Stuff that we had cleaned. We used to teach that in this class, like get out the sandblaster and we're going to clean up these spark plugs and put them back in. Oh, hell no. So my point was, that's it. That's all the ignition system right there. That's all there is. So this is on the distributor shaft. That's on the distributor shaft. They turn at the same time. And you can see that the distributor is secondary and primary. You can see that the coil is secondary and primary. So this system worked for years and years and years, like way longer than it should. But what happened was two things. Number one, we couldn't handle all this freaking wear anymore. It was just like it was too destructive to engine performance and customer satisfaction. And as a result, we had to get rid of this mechanical setup. So we went to electronic ignition. Now, the good thing about electronic ignition is you already understand it really, really well. I believe I'll explain it in 5 minutes. And the whole ignition system is exactly the same. The only thing that's going to change is this part right here. So we're still going to have a distributor with electronic ignition, but we're going to replace this unreliable mechanical system with something that's electronic. And it was a billion times better, but the thing was, people were scared of it. So when they came out with electronic ignitions, a lot of people left the industry. True story. Why? Because they can't stand to sit in a freaking chair and listen to a teacher. So they'd rather, you know, what, change jobs? Okay, so instead of having the rubbing block and instead of having the breaker points, we're just going to have a trigger wheel that looks like this. And it turns around. And we're going to have a pickup coil, looks like this. I mean, God knows you got to know that by now. And then we're going to put it into what we call an ignition module. And you say, ah, is this the introduction of computer controlled? Yeah, it is. Yeah, it is. Because when we went to electronic ignition, actually things got pretty simple. Because if your pickup coil was good, your problem was your ignition module. That made it simple for me, at least, because I could check. In fact, that's what I was talking crap to this freaking mechanic dude that tried to rip off my wife about. He's like, did you check the pickup coil? Because you know, coils go bad a lot because they're made of very thin material. All right, so let's see. Ignition module, I guess I should say the ignition module amplifies. I'll bet you could ask anybody that works as a mechanic on Holt what the ignition module does, and they'd be bloop, blop, bleep, blop. The ignition module amplifies and refines pickup coil output. Okay, what does amplify mean? Make it bigger. What
Yeah.
does refine mean? Well, we got to get rid of the analog signal, the
Make
AC
it
signal,
stronger.
and we got to make it a DC signal because that coil needs to have an on and an off. It can't be doing this AC thing where it's like more, less, negative, more, less. It can't, that's called an analog signal because it's got a million different values. We can't be having that. The coil needs to have a digital signal, which is ones and zeros, either on or off, right? That's why the switch was the perfect thing for it. Okay, but we can't do that with this thing because it creates alternating current. So what we need to do is rectify it, basically is what this thing does. Okay, so what does amplify mean? Amplifies and refines. So amplify means make bigger.
Makes it stronger.
Yep, because that's a very weak signal that comes out of this. Make bigger, make stronger, however you want to say it. And refines basically means rectify and clean up equals turn AC, which is what the pickup coil generates, into DC, which is what the ignition coil needs. Yeah, good luck finding any mechanic in Montclair that can explain that besides me. Okay, so let's say this is 3 volts, is probably better. Minus 3 volts, 0. So this is going to be the signal that the pickup coil puts out. And we're going to notice that it's a very faint, weak alternating current sine wave. You know, and that's what pickup coils do. They don't put out much juice. Okay, let's see what the ignition module output is. Is it 12 volts? Yeah, it's got to be. Getting late now. That, my friends, is a digital signal. It's either on or it's off, right? Here it's got 12 volts. Here it's got 0 volts. That we can run an ignition coil on. So that's what we did. This is the output of the pickup coil. This is the output of the ignition module. We've made the signal bigger, and we've also made it DC instead of AC. Now the ignition coil knows exactly what to do. It's like, yeah, okay. Because the ignition coil doesn't realize that it doesn't have a mechanical switch anymore. Remember, a mechanical switch is on or off. That's digital, 1 or 0. Energized, not energized, open, closed. There's only 2 states. There's infinite number of states. So that's how long it takes to explain electronic ignition when you've prepared your students the way I did. Yeah, okay, so it was easy for me because when we had an ignition problem, no spark, it was easy for me because I would, of course, the first suspect is going to be this freaking pickup coil. But if I tested the pickup coil and it had resistance, continuity, then I pretty much knew it was an ignition module issue. Now, after I tested the coil, of course, but it made it really easy to test the primary. Now, is there a gap here to set? Yeah, but you only set it once with a brass feeler gauge, because of course this is like big magnetism right there. But you only set it once. It's not like it's going to wear out and it's not going to move. So ignition module, I mean, electronic ignition was bitching way easier. Once you get used to it, it's way easier. But it scared a whole lot of people out of this industry, because as soon as they saw this and this, they were like, what the hell? How does that work? I don't know. Some invisible forces, blah, blah, blah. You know, so it scared a whole bunch of people out of the industry. And this is where we began to see that we were growing into technicians instead of freaking mechanics. Because mechanics, you know, Grandpa taught him how to fix his tractor. But this is stuff Grandpa doesn't understand. And it scared a whole lot of people out that probably shouldn't have left. But, you know, every time fuel injection did the same thing for the same reason, because it's electromagnetism. Now, you guys in the freaking first year of a beginning class know what scared the hell out of these people. But, you know, it's like computers used to scare the hell out of people and web pages and stuff. And now it's not so scary because we're kind of used to that kind of stuff. That's electronic ignition. That's all there is, folks. I mean, I wish I could say it was more complicated, but it's not. That's groovy. Now, did it have problems if the bearings in the distributor shaft wore out? Sure. Did we still have the same old problems with the secondary? Absolutely, because we haven't done anything about the secondary yet. So let me show you what you need to see about this video here. That's the one. I swear to God, I've seen this video so many times, so I understand the script better than he does. Let's go right here. We'll just watch this for a minute or two. Ah, that worked well.
Source, you need a transformer. A transformer is of the inductor family.
Wait.
Anything. To create a high voltage from a low voltage source, you need a transformer. A transformer is of the inductor family, and its output to input voltage ratio is proportional to the secondary to primary winding number of turns. Also, it only works with AC signal.
You've been looking at this stuff for months, folks.
So if the secondary to primary turn ratio is 100, if I apply 10 volt AC at the input, I'll have 1000 volt AC at the output. Now for my transformer, I use this one.
That's the one we drew, see? That's the old school ignition coil back when we had distributor ignitions.
It's generally used in a car. It's called the car ignition coil and is responsible to generate sparks across the spark plugs that ignite the fuel in the cylinder. This specific transformer has this wire arrangement, and it has a secondary to primary ratio of around 60.
That's incorrect. That's way incorrect. That's insanely incorrect.
So the output voltage will be 60 times the input.
Yeah, you're not going to jump a spark plug gap with 720 volts. That doesn't make any sense at all. You should know that. But this video has enough redeeming qualities to where it's worth seeing. But I don't want you to be confused about that. 720 volts will not jump a spark plug gap. You're going to need at least 7,000. Well, maybe 4,000, but that's in ideal conditions on a brand new plug.
Here I connected a power cable to the primary to connect it to...
Now he's going to lie about why this coil blows up. The reason the coil blows up is it's supposed to have 12 volts. He puts 120 volts to it. It's going to have 10 times as much current as it's supposed to take. Of course, it's going to blow up. He says it's something about frequency, but he just doesn't get it.
Different transformers work best at different frequencies. This transformer is obviously not made for the 60 Hz city power frequency. But wait, the primary winding is an inductor. Imagine it is this spring. If I force a voltage across it, it will charge and discharge based on what I dictate across it. But if I charge it and then let go, then it will discharge to a very high voltage, way beyond 100 volts. And that on the secondary means more than 10,000 volts. So for example, if I connect my 12 volt supply here to the primary and charge it and then disconnect it.
Now look, he's going to be switching the hot side, but when he connects that wire, it's going to throw current through the primary, which is going to induce electrical charge in the secondary. See, he's got this little electrode coming out of the coil tower, which is the secondary. He's got the ground hooked up permanently. Watch.
The voltage voltage of the primary should jump up, creating a huge voltage on the secondary here that should create a spark. Let's try it out. There's nothing. Is there actually a voltage?
Yeah, there is. Now, the voltage required to jump a spark plug gap, there's not a lot of amperage to it. It's not like it's going to kill you, but the voltage is high enough. It is like a taser. It is it'll sting a little.
Well, my theory was right. Obviously, there is high voltage on the secondary, but the problem is that that high voltage pulse period is so short, it can't create an arc. But there is a way to extend that period. If I add a capacitor on the primary and then connect.
Look at that circuit, simple circuit. You got a battery here, you got a switch here, you got the transformer here. This is a capacitor. We don't talk about capacitors because they're not worth talking about in this class. All a capacitor does is it stores energy just like a battery. What they're going to do between this and there, it's called an LR circuit. What they're going to, well, I'll have him explain it.
The supply, it charges both the inductor and the capacitor. And when the supply disconnects, the inductor and capacitor start oscillating, pouring charges into each other. So the primary voltage will look like this, which decays over time.
AC, right?
I put this capacitor bank together and put it across the primary. Let's pulse the primary now. Look at that, I have sparks. Notice that I have sparks when I disconnect the supply. Now I need to make the sparks continuous, so they go. Now I need to make the sparks primary now.
Okay, when he disconnects the primary, that's when you get the spark because the magnetic field collapses and it dumps all that energy out of the secondary. Now, here's the thing. Do you see that freaking arc? That freaking arc is blue. That's what we want. We want that spark to be blue because a white blue arc is the hottest arc you can get. Just like when you add oxygen to a oxyacetylene torch. You know, if your spark is yellow or orange, that's a weak spark. This one is blue, and you can see that it's traveling probably 3/4 of an inch.
Notice that.
Now, that's going to do groovy things on a spark plug inside the cylinder where, you know, you got hot air, you got all kinds of different confounding factors. So we want to have a big old spark, and we want it to be whitish blue. Now, this is on an old school coil. Unfortunately, this coil has to feed every cylinder. As a result, it doesn't have time to charge fully and then discharge because everything's happening so fast. So it's only going to have time to charge a little bit and then discharge. A coil like this, well, every coil, the faster the engine goes, the weaker the spark becomes. Now, just imagine instead of today's setup where we have a coil on each plug, imagine having one coil for 8 cylinders. Now you've got 1/8 of the time to charge this to make a hot spark. As a result, it was a great limiting factor on how fast our engines could go because the spark just kept getting weaker and weaker. So one thing we had to do is when we went to electronic ignition, there was a good reason. Now, if you go back, that's all the video, that's all of this video that we need to see. We don't need to see a continuous arc, although it is interesting. You might want to look at it. You might want to, you know, watch the video again. Let me show you. One thing I didn't mention about the mechanical switch. Chuck's probably wondering why. One thing about the mechanical switch is it's got a spring, right? That's a return spring. Problem is, if you spin this thing too fast, the spring loses control of the points. That's called point bounce, which is a phrase probably only me and Chuck and 3 other people in the United States have ever heard. But yeah, it's called point bounce. And what it did was it gave an upper limit to how fast you could turn the engine, because as soon as the point starts to bounce, which is to say the spring loses control of the points, you can no longer increase RPM. It's called valve float is the same thing. That's when the valve spring loses control of the valve, right? So now the valve won't close. And when the valve doesn't close, you can't go any faster. So that's why these were both limiting factors onto how fast we could turn the engine. So as long as we stuck with those and we're not sophisticated about that, that was a limiting factor on how fast you could turn the engine. Okay, the Asian Revolution comes in. Toyota, Nissan, Honda, building cars that were getting insanely great fuel economy, getting good emissions numbers, and most importantly, They did it with small engines. Okay, how do you get a small engine to put out power? You have to run it really fast. And the problem is, if you tried to make a small engine run really fast with points, you'd end up getting point bounce. And we would lose control of the ignition system, just like we lose control of the cylinder head when we have valve float. It's the exact same problem. That's why, like V8s, you can't run them 7,000, 8,000, 9,000 RPM. And if you want to, like Ferraris do, you're going to have to spend some serious dollars, because this is not everyday technology stuff. This is hardcore. So one of the main reasons that we went to electronic ignition is, number one, because we wanted to get away from this system that kept wearing out all the time and required continuous maintenance. Just like Chuck's favorite Volkswagen Bug, where we have to adjust the brakes all the time. No, unacceptable. Or like the Model A, we had to adjust, they have mechanical brakes, so we had to adjust them all the time, right? You guys are at the end of a long line of technological innovations. You don't realize how much it used to suck. I mean, we used to have to pour bearings, and then, yeah, it was terrible. Oh my God, let me tell you, quack. Now it's bitching because we got this, all these computers are continuously monitoring everything. You know, how are you going to, okay, let me ask you a question. P0733, incorrect ratio in third gear. That usually means you got a slipping clutch in third gear. How are you going to know that? You're not going to feel it. You're not going to feel it until that transmission is ready to leave you somewhere stranded. Now we've got advanced warning. As soon as it starts to slip, bing, check engine light. Hey, you got a problem, dude. Okay, so we already covered the two first ignition systems, which covers us into like the 2000s. Breaker point ignition and electronic ignition used this setup because they were still using the distributor. And we had to get to the point where we were getting rid of the distributor. Problem was, we knew that the replacement for this mechanical device called a distributor, because look, it's a mechanical device. It's got, you know, it's got stuff that turns, and it's got bearings and all kinds of stuff. We knew that the replacement for that was going to have to be electronic. And that said, we had to get way more sophisticated about our ability to do electronic controls. So that's what we're going to do. And Gabe Alvarado is going to be early next time, because he knows that I'm going to teach him electronic controls. And this is going to be, this is of great interest to me, right? Yeah, it is. So look, we got breaker points. We got electronic ignition. The ignition system is exactly the same. The only difference here is the coil trigger. Remember, we're completing the path to ground. This is ground side switched. As anytime you got the ignition switch closed, we're going to get 12 volts on this post. We got the primary on the outside. We got the secondary on the inside. When the primary has current flow, when these breaker points are closed, we're going to have current flow through the primary. That's going to induce voltage in the secondary. As soon as this switch opens, primary field collapses, which is going to say all this energy is going to go, woo, let me find a path to ground. And we got to make sure that the lowest resistance path to ground is to go up the coil wire, through the rotor, and off to the spark plug and across the spark plug gap. Now, I said something important there. If that isn't the lowest resistance path to ground, all that energy is going to go somewhere else. And that's bad, because that's going to cause a misfire. It's going to cause arcing. I mean, you know, lots of people, they buy cheap spark plug wires, don't have very good insulation, or maybe they've got this laying up against a hot head or exhaust manifold, and it goes through the insulation, and pretty soon you're just getting arcing straight to the exhaust manifold. Misfire, right? Back in those days, we didn't even have a misfire detector. The only misfire detector was, man, it runs bad. Sounds bad, right? It would idle lower, because we didn't even have idle speed control at the time. That was the classic symptom of having a bad cylinder, is that the idle speed would go down. Now, when we started putting idle speed control motors in there, that was great, except when we had a problem, now we didn't have the onboard diagnostics to tell us what the problem was. That's why onboard diagnostics 1, that was a good start. But onboard diagnostics 2, you guys have no freaking idea how great onboard diagnostics 2 is. And what it does is it enables us to put systems of insane sophistication on cars and still not have to worry about, you know, normal schmoes fixing them. Well,
And when we get back into class, I'll bring a OBD1 in so they can see
Laugh.
what the difference is.
yeah, so they can be furious, so they can get infuriated. Yep. Okay. So we must make sure that the path across the spark plug gap is the lowest resistance path. And, you know, we're jumping across air, so it's a high resistance, but we just got to make sure everything else is a higher resistance. That's why we need to have extraordinarily thick insulation on the spark plug wires, and we got to make sure that they're primo shape. So we got 5 minutes left, so let me jump. You know what this thing is right there? That's a wire loom. And the spark plug wires go through that. They better. And if you don't have your looms, you need to buy them. And what's that do? It keeps the wires away from each other. Most people, the loom breaks or they lose the loom, and what do? They get a zip tie and they tie the wires together. Well, you can't do that because these things will start arcing between them. Crossfire is what they called it, because the voltage would come down this wire and it would jump to this wire and fire that plug at the wrong time. Called it crossfire. It's critical that you use the wire looms. It's critical that you do a good job when you're replacing the spark plug wires. And it's critical that your spark plug wires are primo, because as I say, that's the #1 cause of failure on engines, period. That's why, well, that's one of the major reasons we went to coil on plug, because the spark plug wires were so unreliable. Why were they unreliable? Because they're carrying a ton of voltage. Now, what we end up doing on the coil on plug is we're not going to have spark plug wires anymore. The secondary voltage is only going to move 2 inches, and it's going to be surrounded by extraordinarily thick insulation to make sure that it just doesn't arc into the valve cover. But we're going to talk about that next time. It's currently 8:54. You got comments, thoughts on me?
Mr. Rowcliffe, are you gonna end up putting last Thursday's session on YouTube?
Yeah, sorry about that. Yeah.
Okay.
Yep. Of course, you can buy the shirt on Amazon. It works very well for a lot of people. It's not really offensive, but it'll open some eyes. If you have a young person in your life that needs to see this message, it would be a good shirt to wear for your St. Patrick's party. The spark plug gap, let me say, spark plug gap must be the lowest resistance path to ground. If it's not, the electricity is going to go someplace else, and you're not going to ignite the air fuel mixture. That's the biggest, that's what you have to consider when you're dealing with a misfire with a car with a distributor. Look at the spark plug wires first, because a lot of people don't understand the importance of the spark plug wires. As a result, they do stupid things with them. They don't put them in looms. Oh, it's too complicated. Or they have, spark plugs laying on the exhaust manifold, spark plug wires laying on the exhaust manifold, all kinds of crap like that. Let me say, because it's 8:55, let me say that this right here is the spark plug boot. It's the rubber piece that goes onto the spark plug. That's a spark plug boot. Every boot does the same thing. Keeps what's inside in and keeps what's outside out. Okay, well, the spark plug, that goes right there. Just so, do it quick. This boot, like I said, with the breaker points, every time there's a spark, there's going to be metal transfer. So what we need to do is we need to come in here. Anytime we're going to put a spark plug wire on, we're going to get a little pea size drop of dielectric grease. And I want you to put this on every connection. Don't put too much, but I want you to put this on every electrical connection, because what it's going to do is going to keep oxygen away from the connection, and that's going to keep it from corroding. Dielectric grease, it's also called dielectric tune-up grease, also called spark plug boot release, because what happens is when you have a bunch of arcs and you leave the spark plug wires on for a long time, a lot of times it'll weld itself to the spark plug. Now, that's why we say twist, don't pull. These things are dainty things anyway, but there's no point in destroying a perfectly good spark plug wire by not having a good method. On these things, you want to twist them, not pull them. Twist and pull, maybe, but don't just pull them, because if you pull them, I can pretty much guarantee you will destroy this. Now, can you rebuild it after you destroy it? Yeah, but it always comes out terrible. Don't do it. Buy spark plug wires. Spark plug wire is going to cost you 40, 50 bucks. Get good ones, because you're only going to do it once, right? Remember, hopefully. Last thing I'm going to show you on this is, it comes in like this, got a handle like that. And then it comes in here. I think I'll do it like that. And it's got a little mouth thing because it's made of plastic like this. And this thing's made of plastic like this. Those are spark plug boot pliers. Sometimes they're called spark plug pliers. Very, very lovely to have, because otherwise you're going to be fighting them. All they're doing is it's got plastic insulated tips right here, big old thick things. And that's going to enable you to, for instance, take off the spark plug wire while the engine's running, but take off the spark plug wire when it's hot. Remember, twist, don't pull. 859, let me show you, just so you know that it really exists. Go here. Spark plug pliers. Get good ones. Yeah, Lyle's will be fine. Get good ones. Don't get cheap ones. You're going to be sad if you get cheap ones. That's the kind I have. That's the kind I like right there. See, it's got insulated tips. It's rounded here so you can get the boot. So grab the boot pretty close to where the spark plug is, not right at the end, and twist it. Make sure it's all the way twisted, and then you can pull it off. I like the insulated ends. Ooh, that's some really good ones. Like it a lot.
So what happens if you do pull?
If you pull it apart, go buy some new ones.
Okay.
In fact, if you're doing any service, you should probably buy new ones anyway, because you're only buying them every 10 years, right? So I don't like cheap ones because the insulation is so thin. I think you're going to get nailed. And then you'd be sad. You might hit your head on the hood or something. So here it says M103 spark plug wires. It's a special tool. Yeah, but we love them special tools, right? So I'm going to come here and I'm going to go to advanced. Okay, let me just say spark plug boot while I'm here. Actually, it's a wire boot, right? Huh? Yeah, there you go, like that. And we're going to put a little bit of dielectric grease in there. Buy a tube of dielectric grease and you can hand half of it down to your children. But the good thing about that is you will never do something wrong, because I know me, and if I don't have the right chemicals on hand, I'm probably going to say, well, you know, just this time I'm going to take a shortcut. Yeah, and then you make a lifetime of shortcuts. Oh, that's what I was looking at right there. See how beautiful that is? just put a little pea-sized piece. A lot of people fill it up, but that's a huge mistake. Just put a little pea-sized piece right there. When you put it over the spark plug, it's going to go and get in there, and it's going to protect your spark plug boots from welding themselves to the spark plug tip, which is going to destroy your spark plug wires. There you go. So we made very good progress tonight, despite the lack of teaching skill. And we will be able to finish ignition systems early next time. So where are we going? Where we go after that? What do you want to know? What didn't we cover that you wanted to know?
Chime in.
Yes, please.
What about anti-seize on the threads or the spark plugs?
Yeah, thank you for that, Chuck. Absolutely. What Chuck's referring to is, you know, that silver stuff called anti-seize? Let us draw a spark plug. We should be pretty good at it by now. We've been doing it like over and over. Santa's hat goes like that. And then we come down here like this, and we've got threads there, roscas. Well, anti-seize is a conductor, you know, that silver stuff. Buy a bottle of that, and you'll hand half of it down to your children too. And
Down, please.
And you will never be tempted to do the job wrong. Okay, so what Chuck's talking about, and this is what I'm going to warn you. Remember, we got to keep this porcelain pristine. I mean pristine. So anti-seize, I mean, we're putting a steel thread into aluminum head, which means it's going to have dielectric issues. I mean, it's going to create a battery. Dissimilar metals is going to create a battery. Anyway, plus we're going steel threads into aluminum head. We want to protect those aluminum threads. So we're going to use this thing called anti-seize. Now, many people are going to paint these threads. They must go to church regularly. You don't need that. Remember, I told you when we're doing lug nuts, and I can't wait to show you in the shop. When we're doing lug nuts, you don't need to paint the thing. You just put a little bit of anti-seize, because anti-seize spreads like crazy, So I'm just going to put not even a pea size. I'm going to put a very small piece of anti-seize on the threads, and I'm not going to put it at the edge because, you know, if you hit that porcelain, you've destroyed the spark plug. You can't wipe it off. I'm going to put it right in the middle of the threads. Now, you say, well, isn't that going to, aren't the deepest threads going to be dry? Yeah, they are. There's nothing I can do about it because I'm not going to put the anti-seize up here and have it get on the porcelain. If I do, it's going to foul the plug. So I'm going to put it halfway. Little bit. Don't paint it. Anti-seize gets all over the place. Yeah? Chuck, what do you think about that?
Perfect.
That's how you do it? Okay, good. Good. Now we're going to use anti-seize on things like wheel studs. We're not going to paint it. If you paint it, then the lug nut starts to back off. We're just going to use enough to make sure that the threads are lubricated. So anti-seize. Seize means two pieces of metal weld themselves together due to friction. So we're going to use anti-seize to make sure that doesn't happen. It's good because we got to talk about chemicals today, and that's always a good thing. Talk about dielectric grease for all your electrical connections and anti-seize for all your mechanical connections. I think, well, not all of them. I mean, why would you put it on a sheet metal screw?
What's the difference between dielectric grease and electric cleaner?
Oh, well, one's a solvent and the other one is
A lubricant.
Well, I was going to say it's a lubricant, but it really isn't. What it's trying to do is it's trying to keep oxygen away from the electrical connection, because every time you have an arc, if there's oxygen, you're going to have combustion. So if we can keep the oxygen away, there won't be that corrosion, there won't be that combustion.
So it's like an antioxidant.
It is, absolutely. That's exactly what it is, yeah. It's the same reason why we put grease on top of the battery post. It's to keep oxygen away from that joint, because if you have oxygen around the battery post and the battery clamp, you're going to end up with corrosion, because corrosion is an oxidation process, like rust, FeO3, that's ferric oxide. Yeah, all corrosion is oxidation. All corrosion oxidation process. Well, most of it is, put it that way. That's what turns copper, blue. So what we're doing with the chemicals on the battery, for instance, is we're trying to keep oxygen away. What do we do with the CO2 fire extinguisher? We try to push all the oxygen away so that the fire goes out. Well, if you think about it, rust, FeO3, is an oxidation process. Rust is actually just steel burning slowly because it's an oxidation process just like combustion. That's kind of a trip. That's kind of a trip. But it's true. All oxidation is like that. That's what turns copper from bright orange to dark brown. Oxidation.
What ages your body too?
Yeah, absolutely. Sure. Yeah, which is interesting because, you know, people are talking about antioxidants. Well, I mean, oxidation is what makes your food burn, right? Okay, so if you had enough antioxidants, you'd die. So it's a balance, you know.
Exactly what it is. Balance.
I think if you have too many antioxidants, you would probably stay fat, right? Because it would inhibit your ability to burn fat. Fat is a fuel. You still need oxygen. Now, interesting you should say that because we're burning hydrocarbons in the engine, right? Hydrogen and carbon. That's a fuel. Okay, but when we eat carbohydrates, you know, like when people make cupcakes, when we eat carbohydrates, that is carbon, carbohydrate, hydrogen, and 8 means it's got its own oxygen. That's why carbohydrates turn themselves into fat so fast, turn themselves into energy so fast too. But it's like a hydrocarbon that carries its own oxygen. Basically what we're doing with nitrous oxide, right? NO2. We're bringing N in, but it's bringing 2 oxygens with it. As a result, we can stick a lot more fuel in there. It's basically increasing the oxygen density of the incoming air. As a result, we can put in more fuel, we get more power, 150 horsepower on, you know, 300 cubic inch engine. Now, is that going to beat the hell out of the engine? Sure, but it'll go fast. Now, it's 9:09, so I'm going to go ahead and keep talking. If you guys want to leave, you're more than welcome to, but my friend Matt has a 68 Mustang California Special. Bitchin' car. But, you know, when we talked about starter relays, those cars are really easy to steal. The old Fords are really easy to steal. If you can get the hood open, you can take the car. Why? Because the starter relay is right there. All you have to do is hook some power up to the primary. Yeah, never mind. All you have to do is hook some power up to the primary, 12 volts to the primary, and then hook up, go across the starter relay, and that car belongs to you now.
He's a screwdriver.
Yeah. So you know, I don't really want to, you know, I think some of you understand what I just taught, but the rest of you, what we're trying to do is we're trying to figure out a way to keep his car from getting stolen. Now, could he do the fuse and relay thing? Yeah, but those cars are really easy to break into the passenger compartment too, right? Somebody's got their mic on, it's causing issue. So what we need to do is we need to find some kind of security system that can make it so
recording.
I know. So what we need to do is we need to figure out some kind of security system whereby we can protect these older cars, because these older cars are insanely valuable and they're easy to steal. What Matt's suggestion was getting a lock so that it's stuck in first gear, because it is a manual trans. But you know, they can still steal your car. It's just going to be stuck in first gear.
Club.
Yeah, the club, right? So what we're trying to figure out is how can we retrofit these older cars and make them so that they're safe? I mean, my brother had a 67 Mustang got stolen too. Yeah, he got 2 cars stolen in the parking lot at BART in Oakland. What a surprise, you got your car stolen in Oakland. Can you believe he actually moved there from someplace?
Oh. I can't believe it.
Right? Like, man, this is going to be great. I'm going to go to the crime capital of California. Kidding, of course, in case the mayor of Oakland's listening. That's hate speech.
So on those old cars, Mr. Roadcliffe, what about those modern keyless remote kind of things that you can install on them? That wouldn't be a security measure for an old car? Okay,
here's my reservation about that. when it comes to alarm systems, most people get cheap alarm systems. The cheap alarm systems are worse than having nothing at all, because what happens is I get a lot of no starts, and it's because the alarm system. I had an alarm system in the Suburban, and all it did was cause problems. I had to tear the thing out. Well, just cut all the wires basically. Let me ask my good friend Rudy about protecting old cars with security systems. Rudy, can you talk without cutting out? Is Rudy still here?
So,
Yeah, here he is.
All right, let's go. Say something smart.
number one, you get what you pay for. So remember, if you're trying to do it cheap, it's not really going to work. There are ways around it at a lower price, but if you're going to put an alarm system, I would invest the money in at least something good.
How
I
much?
mean, Vipers are some of your best alarm systems out. They range anywhere from about 3,000 to 3,000.
Yeah.
Depending on what extra features you want to have. For example, the alarm I have on the Saturn, it's a $200 alarm, and it ended up shorting the brain out to where it kept trunk releasing opening my trunk, which would leave the dome lights on, which would then drain my battery.
Why would you put a $200 alarm system on a $50 car? That was a joke. Go ahead.
Because at the time I was also in mobile electronics, so I had to have some project.
Okay, folks, I got to tell you, there is no one I know that's sharper on mobile electronics, navigation systems, stereos than Rudy Kaufman. So you need to understand that. You need to be clear on that. That's a resource. He is the Chuck of his generation when it comes to mobile electronics, just so you know. Okay, so what do you do to secure these old cars, Mr. Kaufman?
Your best one's to do an ignition kill, not a starter kill.
Well,
An actual ignition kill.
On the old cars, though, Mr. Rowcliffe, isn't that like, say, for instance, that Mustang you mentioned? Isn't that why they put the locks on the hoods, on the top of the hood, so that nobody can pop the hood and do exactly what
Hood locks make it a lot harder to get into the hood. But understand, nothing's going to stop them from getting that car.
If they're willing to cut out catalytic converters, they're willing to cut out hood locks, is my theory. And these cars, I mean, a 68 Mustang with a nice engine and nice condition, it's probably what, $20,000-$30,000 car.
Or more.
Yeah. So if it takes a small pair of bolt cutters, you know how thieves are. Okay, so ignition kill, how are you going to do it, Rude?
The cheapest way would be do it relay and a switch of your choice that's hidden, and just cut the ignition wire and run it through a relay.
Okay. Everybody understand?
But again,
can you see that circuit in your head, folks?
It was done on my work truck. We ended up putting, because my work truck got broken into when we were doing a job in Oakland. Also, so and they stole the whole truck. They stole the whole truck. So when we came out of the motel room, it was gone. It was gone. They just took it, stripped it. So we went back home, whatever, and he put a kill switch on. My boss ended up putting a kill switch on it, but it did end up causing a lot of problems. And so he had it taken out, and we were having problems when I was at the job site getting the truck started. And that's when he had taught me, he's like, pop the hood. And I popped the hood, and that's the way I was getting it started for the meantime until he took it to the shop, is I was just going to the solenoid, getting the screwdriver, and boom.
Yeah.
Right away.
Yeah.
It also depends on how they do it, because I'd hate to say this, but a lot of shops Mickey Mouse their connections.
Yeah.
And cause a lot of issues.
Yeah.
Seriously.
I don't believe in ever shortcutting my security for my vehicles.
Or the electronics, period, really.
Yeah. if you ever took a look at the alarm system I have on my Saturn, for example, you would see that I have so much freaking protection on the damn system. You'd be like, dude, seriously, why so much? I've got fuses at the battery. I got fuses at the alarm. I got fuses everywhere. But it's because I was dealing with so much high-powered electronics. My car had remote start. It had power door locks. It has trunk release. It has shit, you name it. The only thing I didn't do to it was do my power window conversion to control through my alarm. But my whole car went from being a manual door lock and windowed car to a power door lock and power windowed car.
Why not? Practice, right?
Okay.
Joe Rivera, how you doing?
Good.
Good.
Good. Yeah.
You fixed the car this week?
Yeah.
Good. That's more than I can say.
Keep being a brat.
Good, man. All right, you guys good?
Yep, thank you.
Everything?
Great
Thanks so
class.
much. Yeah, I'll put this stuff on YouTube right now while I'm still frisky, and I'll get both this week's and last week's. Yeah, sorry about that.
Cool.
Okay.
Get excited. Start thinking about cars you're gonna bring into the shop because it won't be long.
I'm already ready. I've been
Yeah.
ready since last semester.
Right. Spring break is going to be from March 22nd to March 26th. They'll put it on your calendar. That means it's only 3 weeks away, and we're going back to school.
Yay.
Yay! Right? Finally.
Can't
So
wait.
yeah. So that's great news. So
Yes.
thanks so much, guys. Appreciate
Thank
it.
you.
And
Have a great night.
have a
Get
great
some rest.
week. You too, guys. Good night.
Bye, everybody.
Nice.
All right, bye-bye.
I'll call you, Chuck. I'm ready.
Huh?
Night.
Good night, Road Cliff. Good night,